All right, good morning, everybody. It is August 8th at 9:02 a.m. and this is a regularly scheduled meeting of the Oil Conservation Commission. I'm Adrienne Sandoval, Chair of the Oil Conservation Commission and Director of the Oil Conservation Division. Would the other two commissioners please introduce themselves for the record?
Madam Chair, good morning. My name is Greg Bloom, and I am the designee of the Commissioner of Public Lands.
I am Dr. William Ampama, designee of the Energy Secretary and also professor at New Mexico Tech.
Also with us is Commission Clerk Florine Davidson and Commission Counsel Chris Moander. First item is approval of the agenda. Is there a motion to adopt the agenda?
Madam Chair, I so move.
Madam Chair, I second.
Mr. Moander, would you do a roll call vote, please?
Happily, Madam Chair. Commissioner Ampoma.
Approved.
Commissioner Bloom.
Approve.
Madam Chair.
Approved.
The motion carries.
Next item is approval of the August 11th, 2022 meeting minutes. Is there a motion to adopt the meeting minutes?
Madam Chair, I so move.
Madam Chair, I second.
Mr. Moander, would you do a roll call, please?
Yes, Madam Chair. Commissioner Ampoma.
Approved.
Commissioner Bloom.
Approve.
Madam Chair.
Approved.
The motion carries.
All right. Next item on the agenda is an update on case number 21872, application of Titus Oil and Gas Production for approval of production allocation. And I believe we have Dylan Fuge from the Energy, Minerals, and Natural Resources Department to provide an update on the status of the MOU between Texas and New Mexico.
Good morning, Madam Chair, Commission. My name is Dylan Fuge. I'm the General Counsel at the Energy, Minerals, and Natural Resources Department. And I can give the Commission the following update on the MOU. Actually, we ended up calling it an MOA with the Texas Railroad Commission. We were able to successfully conclude negotiations with the Railroad Commission in the last week or so. The document was fully executed by both parties last Friday, September 2nd. And we are currently working on, at least on the New Mexico side, some updates, a notice to operator, and some announcements just to communicate the existence of the MOA and some of the expectations consistent with my prior reports and this commission's order. The MOA covers allocation of production, and the application of various regulatory requirements to cross-border facilities. And to be clear, the type of cross-border facilities are covered are cross-border facilities with producing intervals and take points in both states from the same well bore. And so I'm happy to dive into a little bit more detail if the Commission has questions. But otherwise, that's where things stand.
Are there any questions from the commissioners or council? Commission, council, I'll be clear.
Question.
Go ahead.
Mr. Fuge, would it be possible to get a copy of that document sent to me and the commission members? Is that?
Yes.
Okay, would you do that? Awesome.
Absolutely.
I think in order to foster discussion, and I hate to suggest we might want to drag you back to a meeting, having the opportunity to review all that and then me discuss it with the commission and then ask you questions, it's probably going to be a bit more fruitful of a discussion. I realize this was all jammed in, so I by no means fault you or anything for not having the document out today. But yeah, I think that might be a good idea, Madam Chair, is if we have questions, or I can speak with you commissioners individually. If there are questions, then we can request that Mr. Fuge reappear next month if we want to ask him anything. Or
that would be perfectly fine with me.
I'm muted and just talking to myself. So general question. I believe it was part of the order we entered into, 8 months ago, 8 months ago, that it was required for the division to provide quarterly updates. With the MOA being executed, does that need to continue, or I think that might be completed?
That'll be up to, I think, your discretion, Madam Chair. What we could do is next month bring this back for review or revision of that order. And then we can modify the order and alleviate the burden on the division to appear quarterly.
Okay. You're kind of coming in and out a little bit for me on sound. I don't know if I'm the only one.
I think honestly, I think my headset is about to give up the ghost. I noticed some exposed wires this morning I hadn't seen before. So they've served well for over 2 years, but the end is nigh. So I apologize for that. I don't have any substitutes readily available.
Okay, so it sounds like maybe, Ms. Davidson, can we plan to go ahead and put the update on the docket again next month? Mr. Fuge will circulate a copy to Mr. Moander of the MOA, and then we can have any discussion that there may be at that meeting and potentially modify the order to alleviate the commission or the division having to appear every quarter for an update.
Yes,
Thank you.
you're welcome.
All right. Anything else for Mr. Fuge before we move on to the next agenda item? All right, thank you for the update. All right, we will move on to case number 22977, which was application of Pinon Midstream LLC to amend commission order number R-21455-A to increase the maximum daily injection rates for the Independence AGI number 1 and number 2 in Lee County, New Mexico. All right, do we have counsel for Pinon and the division?
Morning, Madam Chair. May it please the Commission. Adam Rankin appearing on behalf of the applicant in this case, Pinon Midstream LLC. We have 2 witnesses this morning, and I would like to make a short opening statement.
Okay, let's do a sound check with the division and then we can move to opening statements. Think I see Mr. Tremaine. Are you here?
Good morning, Madam Chair. This is Jesse Tremaine for the Oil Conservation Division. Thank you for a sound check. I am having some issues with the computer audio this morning, so I hope you can hear me. And I am working with the division's single witness, Mr. Dylan Rose Koss, to actually get on right now. He is not yet available in the meeting, but I am talking to him offline.
He looks like he's on the attendee list and I can move him over. I just moved him over to a panelist.
Excellent.
Mr. Rankin, are your witnesses with you, or do I need to move them over to be a panelist?
They are going to be needed to move over to be added as a panelist. They're actually in the room with me, but so we're going to dance around the sound and muting issues, but they also need to be added as panelists. That would be Mr. Stephen Green and Mr. David White.
I see a Stephen. I do not see Mr. White.
I see David White on the screen in grid layout.
Oh, okay. Then he was already over. So I think we've got everybody. Thanks, Commissioner Bloom. All right. I think we've got all of the functional pieces done. Go ahead, Mr. Rankin, and begin your opening statement.
Thank you very much, Madam Chair. May it please the commission. This morning, Pinion is seeking an amendment of the existing commission order R21455A, which would authorize it to inject a combined daily volume of up to 20 million standard cubic feet per day for its Independence AGI number 1 and number 2 wells. The AGI number 1 was previously approved by the commission under the order I just referenced, and the AGI number 2 was separately approved by the administrative approval by the division in SWD order SWD 2464. However, at the time the division approved that administrative order, it did not believe it had authority to grant an injection rate up to 20 million standard cubic feet per day as requested. Therefore, we filed this application with the commission to amend the underlying order. The requested increase in volume is necessary to meet the anticipated acid gas disposal needs of the industry upstream and the operations in the area. The requested 20 million standard cubic feet, for reference, will occupy a volume of approximately 8,200 barrels per day, which is significantly less than what the division usually sees in terms of saltwater disposal wells, which range generally when injecting into Devonian from anywhere from 10,000 barrels a day up to 30 or 40,000 barrels per day or more. So for comparison, the current volume limitation of 12 million standard cubic feet per day would occupy approximately 4,900 barrels of liquid volume at the reservoir pressure and temperature conditions in the injection formation. So it's a relatively modest request for an increase in injection rate. The request will allow the Pinion facility and the injection wells will help avoid flaring and will prevent waste. It will also help prevent the release of into the atmosphere of CO2 and will help assure continued stability and smooth operations at the treatment plant. Today, we'll be presenting two witnesses. The first witness is Pinion's CEO, Mr. Stephen Green. He'll be introducing the company to the commission. He will review the company's footprint and operations in southeastern New Mexico, and he will provide a short background and an explanation for why it is the company is requesting the increased injection rate at this time. And the second witness will be Mr. David White with GeoLex, and he's going to provide the technical background necessary for the commission to make its determination on the request. We'll provide a short history and to get the new commission up to date on the prior approvals and the background on the facility, the geology, and the operations. And then he'll give an overview of the modeling that was done and updated to confirm that the proposed injection rates are suitable for the reservoir conditions. And then I'll also give an update on the fault slip modeling that was done to confirm that there is not a unreasonably increased risk in induced seismicity. With that, Madam Chair, I would ask that our two witnesses be sworn in.
Okay, let's go ahead and let the division make their opening statements, and then we'll swear them in before they each start. Thank you. Mr. Tremaine, do you have any opening statements?
Very briefly, Madam Chair. Good morning, Commissioners and Madam Chair. Thank you for this opportunity. The OECD entered its appearance in this matter for limited purposes. The Oil Conservation Division wants to ensure that appropriate safeguards are met should the Commission amend the underlying order. And the division also wanted to ensure that the division's technical reviewer was available to the commission for to provide some background information about the division's review of the application and to be available for any questions from the commissioners. The division does not object to the application after it's had the opportunity to review the final pre-hearing statements, and so I do not anticipate any significant concerns with the materials that I expect Pinion to present today. Thank you.
Okay, thank you, Mr. Tremaine. All right, Mr. Rankin, would you like to call your first witness?
Thank you, Madam Chair. I'd like to call Pinion's first witness, Mr. Stephen
Madam
Green.
Chair, sorry, I hate to interrupt. Did we get everyone sworn in?
I was gonna have him call the witness and then swear him in.
Oh, I didn't know if you were gonna do, okay, that's okay too. Just making sure we didn't skip over that part.
Okay, sorry, go ahead, Mr. Rankin.
Thank you, Madam Chair. We'd like to call our first witness, Mr. Stephen Green. Madam Chair, I guess you can go ahead and swear him in. Thank
All right, Mr. Green, can we hear you?
Hello, can you hear me?
We can. We cannot see you, but we can hear you. Is that possible to be able to see you?
Sorry, I didn't start my video.
Okay, there you are. All right.
All right.
Mr. Torrance, would you please swear in the witness?
Mr. Green, can you please state your name for the record?
Stephen Green.
Thank you very much. Could you please raise your right hand? Do you swear or affirm that the testimony you give today will be the truth, the whole truth, and nothing but the truth?
I do.
Thank you very much.
All right, go ahead, Mr. Rankin. Thank you.
you, Madam Chair. May I have the ability to share my screen?
Yes. Give me a second and I'll give you permission. Okay, you should be able to now.
Do y'all see my screen?
Yes. Guesses it's going to be a little bit small, but
I will make it bigger
Okay.
so that we can see it.
thank you.
Mr. Green, will you please state your full name for the record?
Stephen Green.
And for whom do you work?
Midstream LLC.
How long have you been employed by Pinion Midstream?
Sorry to interrupt, but it's
Yep.
really hard to hear you. You came across clearer earlier.
Yes. Is that better?
Yes, substantially.
Okay. So I have to turn my volume up.
Yeah,
Okay.
Let me, one moment. Despite having been for 2 years, we're
Now we're getting I'm getting a lot of feedback or kind of like echoey.
Yeah. Just 1 second.
I got my volume all the way down.
So just give me 2 minutes.
No problem.
Sorry, Madam Chair, we're just coordinating our protocol here.
Okay.
So Mr. Green, for whom do you work?
Pinion Midstream LLC.
And how long have you been employed by Pinion Midstream?
We formed in December of 2020, so approximately 1 year and 10 months.
Have you testified before the commission before?
I have not.
Can you please provide a short summary of your educational background and relevant work experience?
Yes, I've got a Bachelor of Science in Mechanical Engineering from Mississippi State University. I'm graduating in 2001. I entered the midstream space in 2008 and have pretty substantial experience in working in sour gas assets, including amine treating and H2S and CO2 sequestration.
And what is your current position with Pinion?
I'm currently acting as the CEO.
And in that role, what do your duties include?
Really overseeing the business strategies of the company for the most part. I've been heavily involved in the technical design and installation of the facilities, but basically overseeing all the day-to-day operations and controls of the company.
And you're appearing as a fact witness, as a non-expert witness today, correct?
That's correct.
And you'll be presenting a technical witness, Mr. David White, following your testimony?
That's correct, yes.
And you're familiar with the application in this case?
Yes.
Is Exhibit A, which was filed with the commission previously, is that a correct and accurate copy of the application that was filed?
Yes.
You're familiar with the commission order R21455A that was entered previously?
Yes.
Exhibit B is a correct copy of that commission order, correct?
Yes.
And then the names, just so for reference, the names of the two AGI wells that we're talking about here are the AGI, Independence AGI number one and the Independence AGI number 2.
That's correct.
And approximately where are these wells located?
They're located in Section 20 of Township 25 South, Range 36 East in Lee County.
And the Independence AGI number 1 has been approved and it has been drilled, and is it currently operating?
Yes.
And the AGI number 2, it's been approved under an administrative order, and it's currently being drilled. Is that correct?
Correct.
And Mr. Green, you prepared a presentation today to familiarize the commission with your company, with Pinon Midstream, its operations and its current footprint, and then also its request to increase the injection rate in both of these wells.
Correct.
Just for clarity, the company Pinon Midstream is requesting to increase the injection rate from 12 million standard cubic feet per day to a rate of 20 million standard cubic feet per day in both wells.
Correct.
And what that would mean is that Pinon could inject a total volume, combined total volume of 20 million in either one or both, or wells simultaneously, or one or the other, in any combination, correct? Let's see, I'm going to go ahead and move my exhibits to the first slide in your presentation, and hopefully we can all see it better this way. And then moving to slide number 3, Mr. Green, we just review for the examiners, give us an overview of the company, its footprint, its current operations, and tell us a little bit about how you came to be CEO and a little bit about the company's background.
Sure, I'm happy to. To provide the background, the idea of Pinon Midstream started with actually with Ameridev. Ameridev approached us in early 2020 with an issue they were having in the basin of not having a solution for handling both CO2 and H2S. As they approached us, we started investigating really, were they the only ones in the region, and how significant of an issue it was. And what we found is that the eastern side of the basin here is heavily laden with H2S and CO2. And given those findings, we come up with the idea of Pinon Midstream of just being solely a solution for mitigating CO2 and H2S for the basin. So, Ameridev really had the need. They were looking for expertise that had substantial H2S and CO2 sequestration expertise. We had a team of engineers that were really, quite a bit of experience in handling such sour gas. And so in 2020, we formed the company and hit the ground running immediately, putting in facilities for mitigating the issues that Ameridev had. They had quite a bit of gas shut in because of the amount of CO2 and H2S that they were experiencing within the region. Pinon was formed with partners Ameridev, who is primarily just a producer within this region. And we also have a partner in Black Bay Energy Capital that's provided the capital for the company to build out. As for the management team, we have got about a combined midstream experience of roughly 55 years of oil and gas expertise. Several of us have pretty significant experience in H2S and CO2 handling. particularly around sulfur recovery and sequestration. I personally spent the very first few years of my career in a sour gas treating facility where we were treating gas that was 32% H2S on the inlet and up to 6% CO2. So quite a bit of experience and understanding of the technical aspects of handling such a sour stream, which is very important for the application we're dealing with. Treating natural gas without CO2 and H2S is a very different technology and expertise. We were fortunate, to have the experience and come in, and really this is pretty second nature and understanding the design criteria for building an asset out with such substantial contaminants. Kind of moving on towards the map kind of provided in the screen here. We'll kind of start off with kind of the hub of our facility, which is the green box, which is our Dark Horse treating facility. At this location is where our 2 AGIs are located. This is where our 2 amine plants are located. We've got 2 400 GPM amine units with a combined inlet treating capacity of 170 million cubic feet a day. We're going to talk about the gathering side of gathering the sour gas within the region and directing it towards Dark Horse. If you look at the blue line that travels from the Dark Horse facility all the way down to kind of the maroon box, the White Horse compressor station, this blue line is a 16-inch sour gas pipeline that we kind of use as a gathering header. We have low pressure pipes that are behind each of our compressor stations that are owned by the producers. They aggregate their volumes to our centralized compression points, particularly the White Horse compressor station and the Gila compressor station in purple. And we also have compression at the Dark Horse facility as well. We then take that gas, pressure it up to roughly 11 to 1,200 pounds of pressure. We have roughly 45,000 horsepower of compression and AGI compression available in the system. And that gathering system directs all the gas up to the Dark Horse facility. We then treat it. We remove the CO2 and H2S. We inject the CO2 and H2S down hole, and then the sweet gas that is left out on the discharge side of our plant is then redelivered into our Grande pipeline, which is a 20-inch pipeline that traverses around 20 to 22 miles out into the basin, where we provide multiple deliveries to multiple gas processors within the region. As we kind of entered the region, one of the things we heard and listened from talking with all the producers in this area is issues of reliability and redundancy were a big concern. So kind of our focus has really been to solve their problem, but provide as much optionality and redundancy as we can in doing such. One thing that we're super proud of, given our infancy as a company and given the complexity of the things we've tried to do, is our safety track record. We've 0 recordable incidents since we started up the facility. And I'll tell you, as you build out greenfield systems, you're really susceptible to incidents early on in your company's infancies. And we've been able to maintain a perfect track record for safety. It's been a huge component of our focus and a big part of our culture as a company, and how we're growing ourselves.
And so you are currently the operations of the company are limited to Lee County, is that right? Mr. Green, just to point out, I think your video may be turned off, so I don't know if you can turn that back on. It's possible so that everybody can see you. There you are. There you are. Great. So let's move on to the next slide, which I think will give us a little more of a timeline.
Yeah, this is kind of this really kind of shows a picture of just how quickly we've progressed as a company here. We formed in 2020, actually December of 2020, and immediately hit the ground running in developing facilities We started construction in March of 21. We were online in August of 21, and we had constructed a portion of our Grande 20-inch gathering pipeline. We had installed our first amine plant, which is a 40 GPM or 400 GPM amine plant, and had commissioned the AGI Independence #1 by August of 2021. So roughly 8 to 10 months is the time frame from when the company was formed to when we were actually physically in operation. Shortly thereafter, after commencing operation, we started commissioning of our sour gas pipeline, the Hondo 16-inch pipeline, and our White Horse compressor station, which was the most southern station on our system. Given another month, we were adding another compressor station for aggregating more production that was coming online in kind of the central corridor of our gathering asset, our Gila system. And then in December of 21, we added our second amine train in service. Moving into 2022, we extended our 20-inch pipeline further out into the basin, giving us more optionality for redelivery of sweet gas to multiple processors within the region. And then kind of moving into June of 22, we actually spudded our second AGI well, and we're anticipating of having that well ready for operations come early October of this year. One thing I want to point out is the importance of this AGI, and that it provides a very large scalable solution to the basin, which is very critical for the production in this region.
Let's talk a little bit about how that looks and your operation of the AGI to date. On your next slide, review for the commission what each of these graphs represent, and give them a little overview about your operations.
Sure. The two graphs on the left are pressure profiles for the subsurface and surface points that we monitor continuously. And so this data on the left-hand side is all of the data that we've aggregated for 2022. And the reason that we're showing this is that we're wanting to show the performance of the well as it's performed with varying amounts of disposal for this year. The trends are very smooth and very constant, and indicate that the well is performing very well, and much as we've modeled and anticipated the well to perform. You'll notice that the purple line is actually the downhole pressure at the bottom of the well, and that reads over to the right-hand side of the graph, and the blue line is the surface pressure of the injection, which reads closer to the left-hand side of the graphs. Okay. And things that we're pointing out is that we've had a couple of issues or instances in our operation where we've lost power, or the downstream markets had issues within their facilities and shut us in. And you can see that we had very minor blips in pressures, particularly in the downhole injection. You can see we typically operate around 7,400 pounds, but as we come off of injection, we lose less than 200 pounds of pressure, which indicates that the well is really can handle quite a bit more injection capacity, is what we're trying to articulate with these graphs here. Moving on to the right-hand side, we wanted to give an idea of what have we done so far this year. So if you look at the graph on the right-hand side, we've got a chart that shows both in metric tons and in million cubic feet of what we've disposed on as a per month basis. The blue chart, or the blue graph here, indicates the amount of CO2 in metric tons disposed of per month. The yellow chart that's layered in on top is the amount of H2S disposed of. And the red line, which is paired with the right-hand side of the graph, is the actual million cubic feet of gas or tag stream that was disposed of in that given month as well. One of the things you'll notice is that our production has some dips, as in it's getting lower as we in the first quarter and second quarter of the year, and you can see it's starting to kind of grow outwards since we've been into May. And what that shows is that the producers in this region, as they come in to produce and drill wells, they actually have to shut in existing gas in order to not affect those wells while they're drilling and completing new wells. And so what you're seeing here in February through April is quite a bit of gas taking offline in preparation of bringing much more gas online. So right now we're currently in the ramp. We are seeing gas being added to our system every day. Now, August looks a little deformed for this map because at the time we pulled this together, I only had 23 days of data to kind of show. But if I were to show you all of August and into September, that ramp goes further out to the right. The matrix on the bottom here just really kind of articulates physical values from the graphs so that you can easily kind of see the comparison of million cubic feet to metric tons of CO2 and H2S that's been disposed.
So, Mr. Green, looking at that chart, okay, it looks to me like in TAG, tag is means the treated acid gas. Is that?
That's correct.
And so looking at that chart, you're by the end of August, you're already approaching 4.5, close to 5 million standard cubic feet of gas per day, and your limit currently is 12 million cubic standard feet of gas per day. What are your projections for the company in terms of when you're going to start running up against that injection rate capacity?
Yeah, it's a great point. And in exactly a year of operation, we've already achieved roughly 50% of the capacity of the existing well. And with current production projections, we're anticipating of being completely full in the well by the end of 2023.
But I think in your next slide, you're going to talk to us a little bit more about those projections, how you've come to them, and then let the commission know the timeframes and why you're asking for an increase in the rate now. So let's move on to the next slide. And if you would just review for the examiners, the commissioners, each of the elements of this next slide so they can understand how you've come to your projections and what the future production in the area looks like going forward.
Yeah, will do. So starting off with this slide here, there's a matrix at the top that we wanted to provide to the commission to give you an idea of what does this tag gas stream capacity equate to from a physical production capacity. So with our current AGI capacity of 12 million cubic feet a day, that roughly equates to around 260 million cubic feet a day of gas production. All right, and giving a specific CO2 and H2O or H2S composition equates to roughly 97,000 metric tons of H2S and 109,000 metric tons of CO2 annually. All right, what we are requesting is an increase in that capacity to 20 million cubic feet a day, which would provide us the ability to treat upwards of 430 million cubic feet a day of produced gas in the region. And you can see the amounts of CO2 and H2S that would sequester as well. Moving further down into of the page here and looking towards the graph, Lee and Eddy counties are probably two of the most prolific regions for oil and gas production in the United States. A substantial amount of growth has occurred and is going to continue to occur over the foreseeable future. What we know about the basin is that it is going to continue to need more CO2 and H2S solutions in order to realize production in this area of the basin. You can kind of see to the graph here, we do quite a bit of research on kind of understanding the history produced within Lee County, and as well as trying to kind of articulate what we believe the growth is going to look like for the foreseeable future. So if you look at the graph or the chart to the bottom, the blue portion indicates kind of historical data of what gas physically flowing out of just Lee County has looked like up to 2022. And you can see we've reached over 2 BCF of gas production. And with the gray line, it indicates the number of completions that have occurred for the history of the region, and the yellow indicates the number of rigs that have been running just in this county. So you can articulate the yellow line and the blue line with the right-hand side of the graph, and the blue and the orange line equate to the left-hand side of the graph for gas production. Well, what we're seeing past 22 and over the next several years of production for just this one county, within 5 years, we're going to add over a BCF of capacity to this region. And in order for us to be able to do that, we've got to have more solutions for sequestering CO2 and H2S. If you move and look towards the right-hand side of the graph, we're providing kind of well density for wells completed since 2018 upwards of 2022. And what you see here is that if you move further west into Lee County and in towards Eddy County, you see a very, very high density of produced gas. Well, in that region, it doesn't have the CO2 and H2S issues that the eastern half of the region does. If you were able to zoom in and look at the green nodes close to the Texas border there, you'll notice that it's not near as dense from producing wells within that region. And the reason is that there's been very limited options for mitigating the CO2 and H2S. And primarily, you typically would find a solution for one, but not the other. And what we've been able to do to bring to the region is a solution for both, and one that is scalable and that can handle quite a bit of production, which we are seeing already, and the projections show that we're going to be seeing for the near future.
And Mr. Green, you're not just getting these projections from crystal balls or looking at data service companies. You're actually getting feedback from companies, operators upstream, who are required to submit their gas management plans and have planning in place in advance of their production. So you're actually getting that communication from these operators directly with projections for what their development is going to be. And so you have some idea 18 to 24 months out or so. Is that correct?
That's correct. A big portion of our business is planning with the producers within this region. It's actually a very critical piece to our existence and the producer's ability to produce the gas. If you think about this area of the basin, Ameredev was ahead of all the other producers in the region because they had existing production that was shut in, and they knew the amounts of CO2 and H2S. Well, a lot of this area is very untouched. Now, the producers in the region are really figuring out what it is that they're dealing with, and they're looking for solutions and trying to plan for infrastructure that's necessary for them to produce this acreage. And we're working with producers every day in planning for volumes and planning for facilities and planning for added treating facilities as well. So we've got projections and a need for ample more gas treating to come in the region. As we said, we're going to be full by the end of 2023 with current forecasts. And there's more gas out there that we can aggregate and treat if given more capacity with our existing AGI well. With kind of the way that the markets are set right now, it's a minimum of a 12-month expectancy for being able to approve a project and get it online at this point. So we really need 24 to 18 months of planning to be safe and ensure that we can meet the deadlines that producers are aiming for.
So in this case, the current status of your operations is that you got the Independence AGI-1 currently injecting and disposing of approximately 4.5 or 5 million standard cubic feet per day, with projections that you're going to max out that capacity in the next 12 months, knowing that you're going to need another 12 to 18 months from today for planning purposes to get the infrastructure and capacity in place to meet future demand. So in short, I guess, Mr. Green, that's the reason why you're before the commission right now, while the AGI number 2 is currently being drilled, you're already asking for that increase in capacity at this time in order to meet that demand.
That's correct. We can't go out and contract and help plan unless we have the capacity available to us.
Well, let's just move to your last slide and give the commission an overview of the location and just review for them what this is and what we're looking at here in this next slide.
Yeah. So we're looking at a view of the Dark Horse treating facility, and we're actually looking from the west east. So back over towards the horizon is the town of Jow. All right. So if you look over to the left-hand side of the screen here, this is the Independence AGI number 1, and it's been in service since August of 2021. You can see there's a rig on site as we're currently drilling our second AGI well that we spudded in June of this year. And we're currently around 16,000 feet is where we're located. So roughly about another 2,000 feet of drilling remaining, which we're anticipating to be complete within the next 2 weeks or less.
And that's under the current order. You guys are required to have the second redundant well completed the first part of November. Is that right?
That's correct. And we're on pace to be ready for operation come October.
With that, Madam Chair, I have no further questions of Mr. Green, and we'll pass them to the division and the commission for questioning.
Thank you. Mr. Tremaine, do you have any questions for the witness?
I do not have any questions for the witness. Thank you.
Thanks. Commissioners?
Madam Chair, I have no questions.
Madam Chair, no
Luna?
questions. No questions at this time.
Okay, I have a couple questions. Just generally, so there are, let's see, a lot of requirements within the order that you were issued. For example, let's see. You're supposed to send in reports to the OCD. There were some quarterly pieces. Can you just affirm that you have complied with all of those requirements that are currently within your order?
We have, yes. And as a matter of fact, if you look at one of the slides, it shows some of the data that we've reported to the commission.
Okay. And prior to operation of AGI number 2, are you submitting a modification to your H2S contingency plan, or was that already in your current H2S contingency plan?
I believe it's already included in our H2S contingency plan, but I need to go back and verify that.
Okay. Yeah, I think it was requirement 8A regarding the H2S contingency plan. Just ensure you just take note of that.
Yeah, I'll take note. We'll provide an answer.
Why did, I guess when this well was originally permitted, so when you submitted the application, what's been the change between the original ask of 12 and the 20? Or why did you originally ask for 12 and not 20?
Well, the original 12 was very early in the understanding of what are we solving for in the basin. So the original 12 was actually asked by a producer and a Ameridev. And mind you, they started the permitting process over 2 years in advance, trying to solve their own problem. Now, the thing that Ameridev understood is that they didn't have the technical expertise to understand and really operate and build out, but they knew they needed a scalable solution for the amount of CO2 and H2S they had. So when they stepped into this, their goal was solving their own problem. Well, when we got involved, the permit was already provided for the 12 million cubic feet a day. And so during that time, as we're solving AmeriDev's issues, we're out looking for third parties and other producers in the region that we know are having the same issue. And as we've started aggregating more volume, and we do have more producers than just AmeriDev delivering into the system, and we are disposing of their CO2 and H2S, we quickly understood that we were going to outgrow what we had. And that's what we're trying to solve for today.
Okay. And just to confirm, you're asking for 20 total
Yes,
between the two wells. So you will never be injecting more than 20 total
that's correct.
between the two. Okay. Are both of these wells constructed in a manner that you think they can handle 20 as opposed to 12?
Yeah, our technical witness, David White's going to give you the details associated with it.
Okay.
But with everything we reviewed, it is. Yes, ma'am.
And then I think Mr. Rankin hit on this briefly, but there is a requirement in the original order. I think it was, let's see. To have, I think you have to begin injection within 24 months after the original order. The original order was November 4th of 2020. I think you in your presentation show mid-October. I am familiar with how construction deadlines can go. Are you confident that you will be able to meet that 24-month deadline?
Yes, very confident.
Okay.
We've less than 2,000 feet remaining of drilling remaining. So we're really kind of through the more difficult parts of the drilling process right now. So we're very confident that we'll be ahead of schedule for November 4th.
Okay. I feel like I had one more question. Oh, this order also requires that you install a seismic station or a seismic monitoring station. Have you done that?
Yes, we have, and it is currently monitoring and communicating with the state where they can see that data real time.
Okay, great. Great, thank you. That was my last question. Mr. Rankin, do you have any follow-up?
Just one, Madam Chair, I appreciate it. Mr. Green, if there is an issue with getting the well completed within the timeframes required under the order also provides for the division in its sole discretion to grant an extension of up to 6 months. And if that's needed, we'll Pinion reach out to the division, notify them that you need a short extension in order to complete the well and get operations up.
Absolutely.
Madam Chair, no further questions from me, and ask that Mr. Green be dismissed unless you have a follow-up.
Thank you. Thanks, Mr. Green. I think you can be dismissed.
Thank you.
Thank you,
Would
Madam
like to call
Chair.
your next witness?
Yeah, with that, we'll call our next witness, Mr. David White.
All right, Mr. White, let's make sure we can hear you.
Yes, can you hear me?
There's a little bit of echo, but not terrible.
Yeah, we're coordinating our mute strategies.
Mr. Torrance, would you please swear the witness in?
Hi, Mr. White, could you please state your name for the record?
David White.
Thank you. Could you please raise your right hand? Do you swear or affirm that the testimony you give today will be the truth, the whole truth, and nothing but the truth? Thank you.
Go ahead and proceed, Mr. Rankin.
Thank you. Mr. White, will you please state your full name for the record?
David Allen White.
By whom are
Geolex Incorporated.
Have you previously testified before? And were you previously qualified as an expert in petroleum geology, seismic interpretation, and fault slip probability modeling? And were those credentials accepted and made a matter of?
Yes, and yes, they were.
And did you contribute to the analysis supporting the C108 application that was filed and approved administratively for the Independence AGI number 2 and is marked as Exhibit D in the hearing packet?
Yes.
And will your testimony and opinions that you provide today evaluate and address the basis for Pignon's requested increase in injection rate in both the AGI number 1 and number 2 wells to a combined total of 20 million standard cubic feet?
Yes.
And will you also address the potential for induced seismicity as a result of that injection?
Yes.
Did you prepare a PowerPoint presentation today that will review your analysis, conclusions, and opinions on those topics?
Yes, I did.
And you're prepared to review those with the commission right now?
I am.
Then with no further ado, I'm going to set up your presentation so we can all see. And Mr. White, has this been marked as Exhibit E in the exhibit packet?
Yes.
And I will put this on the screen so you can see it. And we'll start walking through. Mr. White, we just briefly summarize what it is that the application requests, and then just walk through the exhibits. And if I have any questions or would like to clarify anything, I may briefly interrupt you. But otherwise, Mr. White, please just review, and I'll advance the slides as you direct.
Sounds great. And yeah, hopefully some of this introduction will be a little bit of a reiteration of things that have been discussed. But in terms of Pignon's request, Pinion is seeking amendment of the existing Commission Order R21455-A to authorize a combined or shared daily injection volume limitation for the AGI number 1 or the Independence AGI number 1 and number 2 wells up to 20 million standard cubic feet per day. And as Mr. Green had previously described, meeting the anticipated acid gas disposal needs of oil and gas operators and production in this area is kind of the justification for this volume request. As Mr. Rankin described in his opening statement, this request, when this 20 million standard cubic feet per day volume under reservoir temperature and pressure conditions, which have been confirmed through drilling and completion of the AGI number 1 well via direct measurement of baseline conditions, would reflect an approximate 8,200 barrels per day being injected into the reservoir. And as the commission and the division are likely aware, is significantly less than typical SWD disposal operations. The current permit limitations, for another comparison, the current limitation of 12 million standard cubic feet per day would occupy about 4,900 barrels per day at reservoir conditions. And utilization of amine treatment and AGI wells at the Pinion facility are really critical components as they have been selected as the primary handling methods of acid gas at this facility. And they really have become a preferred method for that purpose, as they really offer the opportunity to avoid or minimize flaring and prevent waste. And they prevent the atmospheric release of CO2, which some other gas handling methods such as sulfur recovery units don't. In those applications, CO2 has typically been vented and historically been vented to the atmosphere. In making their request, in accordance with the requirements of the original order, Pinion had filed in November of 2021 the Form C108 injection permit application for the redundant Independence AGI number 2 well. And the materials that we will be presenting today with respect to addressing the feasibility of this request were also included in that original redundant well application, which was submitted to the agency late last year in accordance with the Commission's timeline for the redundant well application. So, and if I can give kind of a brief introduction of how the remaining slides are going to go, you know, in past acid gas injection well applications, you know, a complete presentation of all the requirements of the C10 application are included in this presentation. But seeing as how for this particular case, both the AGI number 1 well and AGI number 2 well have been authorized for injection, the main meat of this presentation is going to be twofold. First, providing a general background of the project, the location of the project, the designs of the wells, and the local geology, and then move to focus on tasks more specifically, or items more specifically related to the justification for the amendment to the volume. So we'll begin just with the background information to make sure everybody is aware of some of the basic characteristics of the project. The Pinion Dark Horse Gas Treatment Facility, which Mr. Green described,
Mr. White, I hate
located
to
approximately 6 miles west of Jal, New Mexico. That
Mr.
location,
White,
the surface facility, and the location of the
Am I not being
AGI wells are shown on this map, section 20.
Hello?
The Independence AGI number 1 well,
Mr. White,
Mr. Green described, was completed and brought into service late August of 2021, and it was drilled as a
can we
vertical.
pause this? Can everyone hear me? Can anyone hear me?
Yes.
The Independence AGI number 2 well,
Yes.
also shown at
Okay,
the
so
surface
it
facility
sounds like we're
location,
having trouble
or shown
here.
by the 2 or the red injection well icon on the map,
Madam Chair, you
is
might
being constructed as a deviated well. to
Mr.
put,
White or
so-
Mr. Rankin, can you hear us?
Yeah.
Can you guys hear us?
Yes.
Okay, let's take a second here because I think we're having some technical problems. And it's not just you, Mr. White. I think there's some other stuff going on. Madam Chair,
Okay.
what do you like to do? You want to have everyone log in again or something? Because it looks like we're having both audio and visual issues.
Mine has gotten better now. Was he cutting out? Was Mr. White cutting out for everybody else, or was it just for me?
I did not have an issue after he started his testimony.
Yeah, I'm good from my end. I heard it clearly. Yeah.
Okay. I was having some issues, but you seem to be okay now. So I think let's just proceed.
Okay. And I'm going to turn my camera off too to see if that helps. So I'm not
I
drawing.
did the same.
Okay,
Okay, thank
sure.
you. Go
Thank
ahead.
you. Thank you, guys. Kicking back off, the Independence AGI number 2 also approved through the administrative process, as Mr. Green had described, is currently being drilled and on target for completion or for the completion of drilling activities within the next couple of weeks. In the map shown, we see the surface location for the AGI number 2, as well as the bottom hole location roughly southeast of the Dark Horse facility. The project area, the AGI well surface locations, and the AGI number 2 bottom hole location all stay within the western half of section 20, and that surface is owned wholly by Pinion Midstream. So if we can move to the next slide. And some of this has been discussed, but in this slide, I'm just wanting to briefly discuss the permitting timeline and the facility construction timeline in kind of an organized fashion so everyone can see it. As we previously mentioned, the Pinion Midstream treatment plant was constructed and put into service in late 2021. The facility, again, specifically designed to utilize amine treatment and acid gas injection wells as their method for handling H2S and carbon dioxide associated with natural gas production and treatment operations. And the Independence AGI number 1, which is currently in service and demonstrating a well-behaved performance record, was originally authorized by Commission as a UIC Class 2 AGI well in November of 2020 and was brought into service coincident with the completion and startup of the treatment facility itself. That original order, as we've discussed, has authorized that initial AGI well to inject up to 12 million standard cubic feet per day at a maximum allowable surface injection pressure of 4,779 PSI. And as part of the original order, one special condition required construction and a specific timeline for bringing into service a redundant AGI well, which, while required via the Commission order, has always been the plan for Pinion to have a redundant injection well system, just because it is the primary handling method for acid gas on the site. And with that motivation, Pinion took steps to begin and meet Commission deadlines for submittal of the second AGI well application, the Independence AGI number 2. Within the Commission required timeline, that application was submitted to the Oil Conservation Division for administrative and technical review on November 4th. And as part of that application, the request that we're discussing today to increase the rate, the daily injection limitation to 20 million standard cubic feet, was made as Pinion was at that time better aware of the larger disposal needs of the area. Despite those materials being included in that application, and the approval of the redundant well application on March 31st of 2021, the division had made the determination that revision or amendment to the volume limitation could not be authorized via the administrative process. And we've discussed about how critical the AGI system is for Pinion's operations, but in general, there's reasoning that this handling method has kind of become a preferred method for gas treatment and gas processing operations, in that AGI wells and this method provide the opportunity for a substantial amount of greenhouse gases to be sequestered, which with other options, chemical scavenging and sulfur reduction, traditionally has been vented to the atmosphere. Which ultimately leads to, the AGI projects and systems increase the operational stability of plants, especially when redundant AGI well systems are in place, so that overall it reduces waste and air emissions, both from flaring on the facility sites as well as in the field, with that increased operational stability. And as proposed, Pinion's and the forecasts for development in the area, the proposed 20 million standard cubic feet per day limitation would allow Pinion to be able to meet the needs of those operators. And as we see in the last bullet point, when taken on a per day basis at these proposed injection volumes, there's a significant amount of CO2 and H2S that is sequestered. Now, to remain compliant, even though the C108 application that was submitted and approved by the division, even though it was unable to make any amendment to the allowable injection volumes. The redundant facility is still very important to Pinion's operations, and as such, they had continued in their effort to drill and complete that approved well. As previously discussed, the AGI number 2 well was spudded in mid-2022 and currently is fully on track to meet all of the commission's deadlines for completion and service that were described in the original commission order. Okay, so moving on a little bit from kind of the permitting history and the approval history, I want to take I'll take a few slides to discuss the design of the AGI well. And in this slide, I'm showing a brief schematic of the AGI number 2 well as it was proposed and as it's being constructed. And while this is the schematic that I'm showing, the ultimate design and design standards are in accordance with those that were implemented for the AGI number 1 well. Similar to that well, the redundant well incorporates all AGI best practices, as well as specific input from the NMOCD technical staff that was communicated during the application process of the AGI number 1 well. This ultimately resulted in a 5-string casing design that allows for individual isolation of the shallow Salado salt section, and then specific isolation of the Capitan Reef Formation through use of external casing packers and some diverter tools. For both wells, critical intervals of casing and tubing, such as the base of the well where lower well components are, where water may be more likely to be present, are specifically designed of materials rated for acid gas service, specifically the use of Inconel 925 and G3 nickel alloy corrosion resistant grade casing. And you can see those being utilized in the well schematic in the lowermost interval. In addition, the AGI number 2, as well as the AGI number 1 well, have been designed and utilized downhole monitoring equipment and safety equipment with a subsurface safety valve typically being installed about 250 feet below the surface, which allows for a downhole isolation point that can be integrated into the plant system and also just provides protection against any backflow of material out of the wellbore. Both wells are also equipped with downhole pressure and temperature sensors that are installed immediately overlying the permanent injection packer and provide real-time pressure and temperature conditions along at that depth interval. All of the safety equipment and monitoring equipment are also constructed of Inconel 95 or equivalent materials that are fully rated for acid gas injection service. And in this slide, we'll take kind of a more diagrammatic look at a 2-well AGI system. For the current Pinion operations, the acid gas stream is approximately 70% CO2 and 30% H2S. And to kind of call back to Commissioner Sandoval's question about the H2S contingency plan, that ratio of gas is in agreement with the current plan. And prior to any injection operations at the elevated rate, that H2S plan would be fully updated and approved to be reflective of those operations. But starting from kind of taking a look at the diagram again and starting kind of from the top right, for the acid gas injection system, coming off of the amine treatment. The stream of CO2 and H2S is transmitted to or from the amine system to surface compression or to a surface compression facility at the well site, where it is then compressed to approximately 1,500 to 2,500 PSI, and then transmitted to the AGI wells via corrosion-resistant pipelines that are equipped with automatic safety valves, again, to provide many isolation points and to prevent backflow of materials. The gas is transmitted to the injection trees, which are specifically designed, they're specifically constructed dry acid gas injection trees, which, like many other components in this system, are made of appropriate corrosion-resistant materials. Moving down the well bores of these two diagrams, we see the placement and annotation for the downhole subsurface safety valve, which is exceptionally useful in the event of some emergency or something that may limit the wellhead's ability to contain gas. You've got valves upstream of that and valves downstream of that that can allow for pretty specific isolation of that system. At the lower portions of the well, we see annotated the permanent injection packer and the placement of the downhole pressure and temperature gauges that provide real-time monitoring of the base of the well conditions. And while it's not pointed out or described in this slide, I'd also like to describe a little bit the complete picture of monitoring that goes on with the AGI wells that are constructed at the Pinion facility. In addition to the continuous monitoring of downhole pressure and temperature conditions, there's also continuous monitoring of surface injection pressure, surface injection temperature, surface annular pressure conditions, and gas flow rates. These are all communicated to the plant control room in real time, and the combination of these real-time data sources ultimately allow for the very rapid identification of any issues in the system, whether it's, you know, an integrity loss in the tubing or things like that. Those sensors really allow for really rapid identification of those issues. And with a two-well system, you can, from those indications, make appropriate changes in your operation. And here we have just kind of another look at the project area, more specifically focusing in on its location relative to the nearby city of Jal. As we discussed previously, the facility is constructed on lands wholly owned by Pinion, specifically the west half of Section 20, and it's approximately 6 miles from Jal, New Mexico. And then in the last point of this slide, I just include the specific coordinates for the surface locations of each AGI well. Moving on to give a little bit of the background of the geology of the area. In the top panel, panel A, we have kind of a generalized map showing the major areas of the Permian Basin. And in the bottom panel, we kind of see a cross-sectional view of the Permian Basin, obviously seeing the significant depths that are reached in the Delaware Basin side of things versus the Midland Basin. For the Independence AGI number 1 wells and the Pinion facility, those operations are located in the eastern margin of the Delaware Basin. You can see in the map the annotated location of those facilities and wells. In this area, surface deposits are typically aeolian and alluvial, with some local exposure of Triassic red beds. And underlying the surface location are approximately 9,000 feet of Permian strata, which overlie 8,000 feet of older Paleozoic strata. And we'll take a more specific look in the next couple slides at what overlies and underlies the injection zone and its their relationship to production in the area and things like that. But within the area, there's excellent coverage of the regional Woodford Shale, which is a well-demonstrated and regional caprock in this area that provides the containment for injected fluids into the reservoir that both of these wells target. In this area specifically, the Woodford Shale is approximately 300 feet thick. So quite a good thickness of that well-demonstrated caprock at the Pinion location. Both wells target what is often referred to as the Siluro-Devonian, which is inclusive of the Devonian, Ricin, and Fusselman Formation strata, which are common targets for disposal operations for many SWDs, AGI wells, and has a well-demonstrated history of being productive receptors of injection fluids. In the area, being near the eastern margin of the Delaware Basin, there are instances of normal faulting that typically are oriented or trend parallel to the northwesterly trend of the Central Basin platform. And we'll take a look at those in a little bit more detail in the slides to come. Here is just another kind of generalized stratigraphic correlation for the Permian Basin. A lot of the regions of the Permian Basin that were represented in the previous slides map are included and described in this slide. The highlighted section in the slide shows the Delaware Basin stratigraphy, and obviously highlighted because that is the area of the Pinion project and facilities. And within those strata, we have annotated the formations in which historic or active production has occurred. Not necessarily widespread, but within a reasonable distance from the locations that those are the formations which has had some history of production. So before you advance, and we can take note of this a little bit more in more detail when we get to, the data collected from drilling the Independence AGI-1, but ultimately there's a significant vertical package of geologic strata that separate the approved Siluro-Devonian injection zone from overlying producing zones. And here, diving right into that, is kind of, in this slide, we're reporting the formation tops that were encountered for drilling the Independence AGI #1 well. And we see, again, that looking at the most, or the right portion of the stratigraphic, or of the well log shown there, we see that we've got, between the top of the approved injection zone, where the top of the blue bar marked injection interval is, and kind of the interval of potential production in the Strawn, Atoka, Morrow section, we've got well over 1,000 feet of separation between that, which kind of illustrates the actual data collected, and confirms kind of the information shown on the previous slide. Taking another look at some of the background geology info of the area. In this slide, we show a structure contour map generated from subsea elevations of the top of the Devonian. So it's essentially a structure contour map that illustrates the shape, the dip angles of the top of the Devonian reservoir there. And we can see The AGI number 1 well location annotated at the very proximal to, or at the A point in the A to A prime cross-section trend line, which we'll discuss in the next slide. The AGI number 2 being the second node of that trend line, and then finally another nearby Siluro-Devonian penetration marking the A prime location in that trend line. But we see the AGI-1 and the Pinion project area being located down dip of a local structural high in the area and kind of bounded with larger fault features to the north and to the east. And if we can move on to the next slide, we'll take a look at the cross section that trend line is illustrating. So we see that cross section in the figure to the right here, and one thing it certainly illustrates the paucity of well log data in the area, which from a injection well operation standpoint, you know, it equates to fewer penetrations and fewer potential issues of gas migrating out of the reservoir, but it certainly makes investigating the deep subsurface a little more challenging to have less control. And so for both the Independence AGI number 2 application, the original AGI number 1 application, and those projects, analysis and evaluation of 3D seismic data covering the area was an absolute necessity to make sure that productive intervals of the reservoir where injection operations can be maintained safely is identified. So we see in the well data that are available and are inclusive of data collected from drilling and completing the AGI number 1, we can see the porosity profile and certainly see the local coverage of that thick interval of Woodford Shale, which behaves as the caprock material or the primary containment layer in this area. As secondary containment, you know, this Woodford Shale is also overlaying, and these data were confirmed by drilling the Independence AGI number 1 and collecting sidewall core data. But overlying the Woodford Shale is the overlying 950 feet, approximately 950 feet of Mississippian carbonates of the Osage Formation are also characteristically very low porosity and permeability units. So they could provide additional protection and confidence that the gases injected in this area are going to be contained within the target.
Madam Chair, are we done with the geology review?
Yeah.
Madam Chair, having completed the background section here on the geology and history, I want to check to make sure that, about being an hour in, I want to make sure the court reporter is doing okay. And if we want to take a break, we could take a quick break now or continue into the modeling, which will be the next topic of testimony.
Okay, why don't we take a 10-minute break and come back at 10:40?
Take a break to 10:40.
Can you hear me?
Yes.
Yes, yeah, that
Okay.
works.
All right, we'll be back at 10:40.
The volume again. Okay, so now that we've kind of covered a lot of the background information on the project and the local geology, I want to move into the additional work that's been completed in advance of the submission of the original AGI number 2 C108 application. And there we go. Nope. No. 18. Okay, and so I want to talk about the additional work that's been done that more specifically focuses on the justification and the request to amend the allowable volume to 20 million per day. And this additional work has really revolves around two questions. The first being, is the reservoir, is the injection reservoir and our understanding of it currently suitable to support this injection rate being requested? And what impacts will that have on the reservoir? What will the resultant plume look like? And then also, what are the risks of induced seismic events in response to this change in the allowable injection volume? And so this work really started with first updating the existing geologic simulation model that was presented in hearing for the AGI #1 to be inclusive of not only well log data, but the results of reservoir testing that was performed during the drilling and completion of the AGI #1, and to revise that model to better reflect our understanding of the subsurface now, and also build in and consider the AGI #2 and its injection contributions into the reservoir, with the ultimate goal of trying to understand, after 30 years, what does the resultant acid gas plume look like in terms of its dimensions? What are the concentrations of acid gas within the reservoir when these wells are operated as proposed? And then finally, just reevaluation of the slip probability and the risk for induced seismicity in response to operation at 20 million standard cubic feet per day for the two wells. Or to be clear, shared by the two wells. And so we have a little bit more background in this, in that in our evaluation of both the original AGI #1 well and our evaluation and development of the permit application for the AGI #2 well, in both of those instances, 3D seismic data were reviewed in order to site locations, and of course were revisited and reevaluated at the time of permitting and developing the permit for the AGI #2 well. In this map, we showed the faults that were identified in the area, and to confirm, even through reevaluation during the time of AGI #2, our interpretation of those subsurface features remains the same. So we've identified 8 faults that typically trend in line with the northwesterly trend of the Central Basin Platform, with a few smaller features that are semi-perpendicular to those. As we described previously in the Devonian in the slide where I discussed the Devonian structure map, the nearest faults to the location are the large north-south feature to the east of the well locations, and then the northern fault there. And so in updating or in utilizing a reservoir model and simulations to understand the resultant plume, similar to the AGI #1 application efforts and similar to what was presented in that associated hearing, we have utilized the Schlumberger-Petrel platforms to construct the geologic simulation space, which effectively can be thought of as the digital container in which injection operations are simulated, and then the associated Schlumberger Eclipse platform to conduct those simulations that include both the proposed operation of the AGI wells as well as the operation of nearby SWD wells. And so in this slide, the map shows it shows a map view of the geologic model that has been constructed in terms of its dimensions. it remains the same as the Independence AGI #1 well in terms of its aerial expanse, covering about 20 square miles in southeast Lee County, New Mexico. The boundaries of the simulation space were not increased for a couple reasons. One being the number of wells that are included in the simulation did not warrant that those be expanded. And then secondly, the expanding of the model in an area with limited well control and outside of the coverage area for our seismic would lead to a lot of assumptions being made about the characteristics of the model in that space. So for this period and these investigations, it was not warranted to increase that space without knowledge of how to characterize it. While the model dimensions have not been changed, the characteristics within the model, so porosity and permeability characteristics, we have gained important data from drilling the AGI #1 and #2 that allow us to better represent the subsurface characteristics for our simulations. And in this slide, we showed just a three-dimensional render of the actual model that was produced. While in the image, the color codes are generalized into 8 discrete zones that are stacked vertically within the reservoir. The total simulation is comprised of 292 simulation layers, which are then additionally subdivided into 500 by 500 feet grid cells, leading to a rather large area in which injection operations is simulated, with the model size reaching 920,000 grid cells. And so in this slide, we provide kind of a summary table of how the 8 identified zones are the characteristics that are ascribed to them. And these zones were generally delineated based on their porosity and permeability characteristics. And so we see that, you know, upper zones appear have varying average porosities than lower zones, and those are generally reflected in that, and this is the summary of how those are reflected in their average values in the modeling. Taking a high level look at it, the average total porosity within the 8 zones of the injection interval is 4.2%. This is based on our interpretation of well logs and drilling the Independence AGI #1, and then the permeability values that were utilized to inform the model, again, were based on what drill stem test data are available, Independence AGI-1 injection test data as a step rate injectivity test, and long-term fall off test was performed, and then further refined by the larger or significant studies on dolomite permeability. And so moving to this slide, the panels that are shown in this slide are we're showing how porosity and permeability is actually distributed within the model. As we discussed, we do have these porosity and permeability estimates are generated from what limited well control we do have, and then further supplemented through analysis of the 3D seismic data and specifically mapping of impedance characteristics in the area. So we see, taking a look at, and you'll have to forgive me if the scale is small, but in the top left chart, we essentially have the distribution of porosity within the model. And you can see that general population ranges from about, 0 or very near 0, or maybe even more generally 1% porosity to about 6% porosity for most of the population. and that is essentially how that's distributed in each of those 920,000 grid cells. So that's the total population. And then moving over to the panel to the right, we see how permeability, for a brief second, we saw how permeability was distributed in the model. Yeah, so seeing this distribution in the bar chart with the blue colors, we see that permeability for most of the population ranges from around 0.1, 0.2 millidarcies to about 30 millidarcies, and you see the corresponding frequency of those values shown in the vertical axis of that bar chart. With both permeability and porosity, based on our experience drilling AGI wells and completing AGI wells, testing the Siluro-Devonian reservoir via injectivity tests, the way these characteristics are described in the model is in accordance with what we see. With what we see in actual wells drilled, completed, and operated. Oh, actually, Adam, if you can go back one more. And on sorry, I failed to describe the bottom panel there. And what is shown in the bottom panel is just a cross plot of the model permeability cross plotted against the model porosity. And it shows essentially, you see, looking at the data, you can probably pick out that there are 8 unique trend lines where, you know, those 8 discrete vertical zones each correspond to a colored trend line in that. So obviously that we can see that there is, in some zones, the model represents a stronger correlation between porosity and permeability than others. So we can essentially expect that those zones with a stronger increase in permeability with increases in porosity will be larger receptors of acid gas. And so in this slide, again, this is described, this slide is intended to show you how characteristics are represented in the model. And from those, and essentially what is being shown here is a porosity map. So we're looking map view top down again at the simulation space, and we have the porosity distribution within the model zones 1 and 7 and 8, which based on the way porosity and permeability is distributed are anticipated, and in fact the results show that they are the two primary receptors of acid gas in our simulation. And also that's in accordance with our experience with Siluro-Devonian acid gas injection wells. So moving on from how the characteristics of the model are set up, with this geologic model constructed, we're able to simulate injection operations and start to get some insight into our initial question of can this reservoir, as we understand it, sustain these operations that we're proposing. And just to recap, in this slide, I'll recap the specific conditions of the injection simulations that were reported. The AGI wells were simulated to inject a mixed acid gas stream, again, of 70-30 CO2 to H2S in accordance with Pinion's current operations. And the simulation was conducted for a period of 30 years. Acid gas properties, the density and volume based on temperature and pressure conditions were determined utilizing the NIST RefProp utilities, which is a comparable utility to equilibrium, which has been referenced in many acid gas injection well applications, and essentially allows us to understand the acid gas characteristics for a given temperature and pressure. For the injection wells included in the simulation, both the AGIs and SWD were operated at their maximum anticipated injection rates, which correspond to the permitted injection rates for the entirety of the simulation in order to provide the most conservative results and assurance that the operations are reasonable. The simulation assumes the reservoir is a brine saturated reservoir in hydrostatic equilibrium, and the boundaries of the simulation, because of our understanding, are kept closed, and we assume that faults are barriers to flow or non-transmissive, which is a common assumption and is supported by what we know about a lot of these deeper Paleozoic faults, which have a long history of trapping productive resources and demonstrating that they're not really transmissive of flow. So in the work presented today and in the C108 application for the AGI number 2 well, again, which was submitted at the end of last year, 2 simulations are presented here. The first being injection via the AGI number 1 and number 2 well at an injection rate of 10 million standard cubic feet per day for each well, which is shown there, would equate to approximately 4,100 barrels per day for each of those wells. And this scenario was selected while we've explored several scenarios. This scenario was selected as the most reasonable because from an operational standpoint, it's kind of the ideal way to operate this well and to manage reservoir capacity. It would be not very suitable to plan to inject into one well for long, as it strains surface equipment more and ultimately has a greater and more rapid impact on local reservoir conditions. So for what's presented today, that was deemed as the most suitable and most preferable for long-term operation of the wells. The second case being presented is similar in terms of the AGI well the operation of the 2 AGI wells, but then it also considers operation of the nearby West Jalby Deep SWD at its maximum expected rate of 30,000 barrels per day. So now, after a good deal of discussion about the foundation of the model and the next and the simulation conditions, the next couple slides we'll be taking a look at the results of that simulation. And this and the next slide will follow the same format in that we see in panels A and B the maps that show, one, the aerial extent of acid gas within two zones that are the primary receptors of acid gas, that show the aerial extents as well as map the gas saturation at the end of the 30-year injection simulation. Panel C will show kind of a resultant polygon that amalgamates the lateral extent of all 8 zones to kind of show and illustrate the maximum dispersion distance of acid gas at year 30 at the end of the injection simulation. And panel D will show a cross-sectional view that illustrates, both being a north-south cross-sectional view, that illustrates the distribution of acid gas vertically as a result of these injection operations that are being simulated. So looking at these results, we see that at the 30-year mark, we see acid gas within zone 1 reaching the farthest from the AGI well location at approximately 2.43 miles from the site. Oh, I think you skipped ahead. We should be on case 1. So for case 1, in which operation is only of the AGI wells at 10 million per day, the maximum dispersion distance we see is 2.3 miles, and certainly it's not a radial dispersion, but towards the north, we see the greatest migration of that acid gas. Generally, acid gas saturation levels are highest near the wellbore, where we see reservoir concentrations within the grid cells ranging between about 30 to 50%. And as we reach the margins of the plume, we start to see gas saturation values lower than 25%. And in case 2, again, following a similar pattern in terms of the results being presented, we see, and this case, just to reiterate, this case would be the same 10 million standard cubic feet per day into each acid gas injection well, but also with operation of the West Jow B Deep at a rate of 30,000 barrels per day. And immediately, one of the first impacts we see is we start to see a little bit more deflection of the acid gas plume away from the West Jow B Deep. So kind of inhibiting migration to the northeast of the AGI well locations. And we see that deflection resulting in a little bit farther reach from the AGI well bores, with the maximum extent reaching about 2.4 miles from the AGI sites. Again, we kind of see a similar pattern in saturation, with the nearest areas to the wells having saturation levels of 30 to 50%, and then being reduced towards the margin of each plume. In both case simulations 1 and 2, we see kind of in accordance with our experience in the Siluro-Devonian, we see zones 1, 5, and then the lowermost zones being the most productive receptors of acid gas. And here we take another look kind of at the results, and what we have plotted here for cases 1 on the top and case 2 on the bottom. And you'll have to excuse me, but case 2 at the title of that chart has a typographical error. It says 15,000 barrels per day, but it is actually should read 30,000 barrels per day. And this has been confirmed that the data represented on this slide are representative of that 30,000. But in both of these charts, we're taking a look at the model's prediction for surface injection pressure required to inject at 20 million standard cubic feet per day, plotted against time. And the 2 yellow trends, the solid yellow representing the Independence AGI number 1, and the dashed yellow trend representing the number 2 well, both show that for the complete 30-year simulation period, that injection can be maintained under the limitations of each respective maximum allowable surface injection pressure for the complete 30-year period of operation. And in this slide, again, this is kind of providing the numerical equivalence of the results shown in the prior cross-sectional view. If you recall a couple slides back, we looked at cross-sectional views of gas saturation, and it was quite apparent that some zones were being occupied by more acid gas than others. This is the numerical breakdown for case simulation 1 on the left and case simulation 2 on the right. And we can see the model predicted volumes of acid gas that each of the 8 general zones will have received at the end of the 30-year injection period. So you see in column 2, the cumulative injection reported in million standard cubic feet per day. And in the following, the column to the right of that, the cumulative injection in million barrels equivalent. And then the fraction of the total acid gas injected that each injection interval or each reservoir zone has received in this simulation. And lastly, the next couple slides just show the initial and resultant pressure predictions for, again, the two of the major receivers of acid gas in our simulations, with that essentially equating to the upper Devonian section, which is a primary receiver in the existing AGI well, and then the Fusselman interval, which is also a recipient of acid gas in the current injection well. And so here we see the same initial and end of simulation resultant pressure maps for case number 2, which should be immediately apparent has some different results, as that simulation considered also a significant volume being injected by the West Jal B Deep SWD well at 30,000 barrels per day for a period day in and day out of 30 years. So just to summarize kind of the results of this investigation, based on our current understanding of the reservoir and our conservative approach to simulating the injection operations within this reservoir, the current model results and our understanding support the ability or confirm the feasibility of the reservoir in this area, and the current injection operations confirm the feasibility of Pinion operating the 2 wells at the combined rate of 20 million standard cubic feet per day. And this is predicted to be feasible for a period of at least 30 years, and these operations can be maintained without any modification to the current maximum allowable surface injection pressures. To reiterate, in our simulations and our work was intentionally designed to be conservative, just so that we can have as much confidence as we can that the work to actually operate these things and attain approval, that we have as much confidence in the reservoir's ability to receive these fluids as we can. So as such, in our injection simulations, all wells were operated at their maximum anticipated or permitted rate, such that those conservative results can be arrived at. In all case studies presented with and without the contributions of the West Jal B Deep, all of those proposed operation splitting 10 million between each well can be maintained through the entire simulation. When looking at the results, no, you're fine. When looking at the results with and without the West Jal B Deep operating, we see a maximum dispersion distance between 2.3 and 2.43 miles from the AGI wellbore. The results of the simulation are also in agreement with what we've seen in drilling and operating acid gas injection wells in the Siluro-Devonian Reservoir. And then finally, and quite importantly, is that with the simulation results that consider the increased volume, what we also see is that the plume, while it is naturally larger due to a larger injection volume, we don't see it migrating or advancing into the path of any other penetrations into the SWD well or into the Siluro-Devonian Reservoir. So we have confidence that no additional pathways out of the reservoir through an existing well that may or may not be plugged appropriately are going to present any issue to this application. And so with an understanding or confidence that the injection reservoir can receive the fluids being proposed in a reasonable manner that can be completed within the bounds of the current maximum allowable injection pressures, the next question becomes, does this increased injection volume present any elevated risk or any significant change in the risk for induced seismic events, as there are faults in the area which have been identified and need to be considered. And so the second part of our reassessment completed for the C108 application for the AGI number 2 and in preparation and being presented today is a reevaluation of that fault slip probability assessment that was completed for both well applications. Again, just to bring to refresh everyone's memory about the local structure, in this map we show again the faults that have been identified in the area. Naturally, the area covers a pretty significant distance, so there will naturally be faults that are a bit more relevant to the AGI locations than others. To kind of reiterate again, these features were identified in review of 3D seismic survey data, which was also reevaluated at the time of each application. And so again, with modeling fault slip probability or simulating injection operations to kind of assess fault slip probability, a series of input parameters have to be identified and defined in the model and subsequent simulations. These input parameters, which are shown in the table here for the work completed for the Independence AGI number 1 and number 2, they essentially are utilized by the model to describe local stress conditions, the orientations and the attitudes of subsurface features, which the model uses to essentially assign pressure values or conditions that are going to be necessary to induce slip along features in the area. In the area of the Independence AGI number 1 and number 2 well, as we've seen in previous slides, most of the fault features are trending in line or parallel to the trend of the Central Basin Platform, with a few minor fault features trending in sub-parallel directions. And while we have 8 major fault features in the area that we've identified, in order to really accurately represent their kind of non-linear expressions in the fault simulation evaluation, those faults have been, as shown in this map, broken down into 29 fault segments, so that those points along those features that may be more in alignment with regional stress directions and therefore more having a little bit higher potential for slip are adequately considered by the simulation. So we'll see in this map how each of those major fault features are broken down and their corresponding segment numbers that we'll see in the simulation results to come. And one of the first things, the fault slip probability model, which I'm not sure if I referenced this, but the model being utilized is the Stanford Center for Induced Seismicity fault slip potential model, which is very quickly become a widely used model for investigating the potential for slip in response to a variety of injection simulations. And based on the structural data and the assumption, the reservoir characteristics that are defined in the model, one of the first steps it takes is it tries to identify what the change in pressure for each of the fault segments being represented, what the change in pressure is going to be that's going to be required to induce slip along that feature. And so what we're showing here is for the 29 fault segments in which we've defined in the model, we're seeing the model's prediction of the pressure required to induce slip along those features. So immediately looking at the model's predictions, we do see that the faults 1, 2, 5, and 6, as shown in kind of the previous fault mapping, are the most, or the features with the most likely, or are the features with the most potential or lowest pressure thresholds to induce slip. With a prediction of, or an assessment of the geomechanics and an understanding of the fault features in the area, we then inform the fault slip potential model of the injection simulation that we'd like to simulate so that it can essentially complete a hydrologic simulation model and start to make predictions about what the pressure impacts of each of those wells will be over the operation or over the periods for which they're being simulated. So in our investigation of the area where the Pinion Independence wells are located, we included 7 additional SWD wells that are operating or are planned to be operated in the area. And what we'll quickly see is, based on our understanding of the reservoir, some of these SWDs are located pretty far away on the eastern margin of the study area, and really are anticipated to have some pretty minimal impact. So similar to the reservoir modeling, we see West Jowl B deep and the AGI wells not being particularly affected by those wells much further out. So actually, Adam, if you can go back one time. So as we can see in the tabulated data for the 7 injection wells that are included in the simulation, we see, you can see that the injection volumes that we simulate range from about 4,200 barrels a day to 30,000 barrels per day, as there are a couple instances of SWD wells operating or being at least approved for injection up to those rates in the area. There is one well, the Jowl North Ranch SWD, that our review of records, it was not apparent what its actual permitted injection value was. So for our simulations, we assumed a value of 10,000 barrels per day. As with the injection, the previous plume modeling simulations, all of the injection volumes or all of the injection operations of these SWD and AGI wells were completed at their maximum daily injection rate, again to provide that conservative estimate of risk and provide as much confidence that the risk of fault slip in response to this proposed operation is not or is a manageable risk. So in this slide, we see some of the results of the simulation of the 7 injection well simulation, which was operated for the AGI wells or for the period in which AGI wells were operated was at least 30 years. However, because some of these SWD wells have been in operation prior to the AGI wells, the total the total simulation duration was extended to account for those historic operations. So with some wells I believe, beginning their operations circa 2010. We see the ultimate simulation period being in excess of 40 years. And in the top panel, we see the FSP models predicted, or the results of the hydrologic model, where we see the pressure front generated from the operation of these 7 wells. And noting immediately that the resultant pressure conditions that the model predicts falls pretty significantly short of what the model also predicts would be the pressure thresholds needed to induce slip along any of those features. And we see each of those features, or the pressure conditions along each of the 29 fault segments, being plotted in the chart to the bottom there. In general, the results of pressure increase along these features ranges from less than 1% to 20% of what the model predicts is the pressure required to induce slip. And in this slide, we also show some other demonstrations of the fault slip probability results, with the top panel illustrating the fault slip potential predicted by the FSP model through time, with each of those fault trends being plotted in the black trend line. So we immediately see that along all 29 features simulated, there's not really any elevated risk of slip probability for any of these features based on this particular injection scenario. For most of the 29 fault segments, the model predicts a probability of 0.00 probability of slip. However, there are 4 segments for which the model does predict non-zero probabilities. And these are shown in the map, the lower map on this slide. We see segments 4, 5, it is 5 segments, 4, 5, 16, 17, and 18, having probabilities ranging from 0.01 to 0.05 based on, or in response to the 7 injection well scenario. So in this slide, we also show again the same plot of model predicted fault slip probability plotted against time in the upper panel there, and then the specific model predicted results, or the specific model predicted change in pressure required to induce slip, the model predicted pressure change for the 7 well scenario, the associated probability that those conditions will be reached and induce slip, and then the final column representing the probability of slip for those 5 features for a subsequent simulation in which the AGI wells are not included. So immediately in that comparison, we see that the volume, the approximate 4,000 barrels per day equivalent that the 2 AGI wells are contributing, are not producing, well, in this iteration, any noticeable change to the probability of slip, which would suggest that any observable risk of slip is kind of being driven by adjacent SWDs, or the higher volume injectors in the area. With that, even considering that, we observe that generally these features, these fault features, these 8 fault features, are generally not predicted to be at significant risk of injection-induced slip for this 7 well scenario. Again, subsequent simulations that remove the AGI injection contributions really produce no noticeable result, or no noticeable change in the probability of slip. And ultimately, as proposed, the AGI wells at 20 million standard cubic feet shared between the 2 wells can be completed, and those wells can be operated without significantly increasing the risk of injection-induced slip in the area. So to just kind of summarize the materials presented, including the background materials and the request of Pinion. Again, Pinion is requesting approval or amendment of the existing commission order to allow for a combined or shared daily injection volume limitation of 20 million standard cubic feet for the AGI wells 1 and 2. These wells, both well number 1 and well number 2, have been authorized for injection into the Siluro-Devonian interval, one via the commission or via the hearing process before the commission, and one via the administrative route. Independence AGI number 2 was authorized earlier this year in March of 2020. However, as we discussed before, the request to increase the total volume limitation was not able to be considered through the administrative process. In our additional work to evaluate the reasonableness and the feasibility of maintaining these injection operations, our revised modeling, which is better informed through drilling and completion of the AGI number 1 well, and further refined through detailed analysis of 3D seismic data, confirms that this is a reasonable request of volume for this area, and the reservoir, both log data and well test data, support its ability to receive these fluids in a safe manner. Summarizing the conditions of the modeling and simulation, again, to reiterate, Petrel or Schlumberger, Petrel, and Eclipse software platforms were utilized in our investigation, and the results of that indicate that based on the 2 case studies simulated, the resultant acid gas injection plume would extend from the AGI wells between 2.3 to 2.4 miles from the current well bores, being controlled and or with the main difference between those 2 case studies being the operation of the West Jalby Deep. The simulation results also confirm that the operation at this rate can be maintained throughout the entire period for which Pinion is requesting, with the results showing that surface injection pressures can remain under the maximum allowable pressures for the entire period. Additionally, revisiting our assessment of fault slip probability or fault slip potential, those results as well confirm that based on our understanding, these wells can be operated as such without any significant risk of producing induced seismic events. So moving back to the ultimate request of Pinion, Pinion would request approval to operate the Independence AGI number 1 and number 2 at a combined daily injection rate of 20 million standard cubic feet per day. The AGI number 2 well is currently being drilled and is currently on target to meet all of the condition of the commission's requirements with respect to the redundant AGI well. Again, to reiterate, the ask of 20 million standard cubic feet per day is a reasonable request and really only a moderate increase, as under reservoir conditions. Again, the acid gas would equate to approximately 8,200 barrels per day within the reservoir. Again, significantly less than many SWD wells operating in the basin. The operation proposed can be maintained without any increase to the maximum allowable surface injection pressures, and as such, we're not requesting any modification to those conditions. And ultimately, as proposed, based on our investigation, the operation at this rate can be done safely, and it will allow Pinion to meet the local needs for acid gas disposal in the region.
Mr. White, in summary, then, it's your opinion that the granting of Pinion's application will protect human health and the environment in this case?
It is.
And in your opinion, will operation of the two AGIs at the proposed injection rates result in waste or impair any correlative rights?
No.
And in your review and analysis, it's your opinion that the target interval here will have and does have the capacity to accept the volumes of the treated acid gas at the rates that are being proposed for the life of the wells?
Yes, I do.
Madam Chair, at this time, I would move the admission of Pinion Exhibits A through E. And the last bit of our presentation is to touch on and review the notice. But I realize that we have proceeded through a lot of material, and the commission may wish to ask questions now, or the division may wish to ask questions now, or we can finish up by just reviewing the notice.
Go ahead and finish up, and then we can enter exhibits, and then proceed with questions.
Thank you, Madam Chair. Mr. White, did GLX prepare and issue notice of this application and today's hearing?
Yes, we did.
And is that notice reflected in Exhibit F of your exhibit packet?
Yes, it is.
And does that exhibit packet include a sample notice letter that was sent to each of the parties?
Yes, it does.
Does it also include all the green card receipts reflecting the status of delivery of each of those notice letters that went out?
Yes. 14 of the notice was sent out. We did receive green cards, routine receipts confirming receipt of those materials. For one certified mailing that was sent, the address was found to be vacant, and we followed up with a Federal Express overnight shipment to a corrected address for one interested party. And then for two additional certified mailings that went out, those mailings are still in transit according to the USPS tracking system. When that in-transit status was identified, we reached out via electronic mail to contacts at those two entities to provide them immediate electronic versions of all of the materials that were sent in the original certified mailing notice. And those correspondence via electronic mail and the subsequent overnight FedEx shipment details are included in this exhibit as well.
And the one party that you received notification that the location was vacant, that was for NGL, Energy Partners, and that address was the address provided on their corporate website, and it still is provided on their corporate website, is that right?
At the time, I don't know if it's current, what is currently listed, but at the time, yes.
Okay. And that subsequent attempt to deliver by overnight mail was successful?
Yes, it was.
And then in addition, Mr. White, did we also prepare a notice of publication in the newspaper of general circulation in the location where the well is located?
Yes, we did.
And has that been marked as Exhibit G? Let me get to it. See if I can get to it. Is this a copy of the affidavit of publication reflecting that notice of this application and hearing was provided in a newspaper of general circulation in the county where the wells are located?
Yes, it is.
And we identify each of the parties, affected parties required to be noticed by name in this publication.
Yes.
And these same parties were noticed as well for the C1 administrative C108 application that was approved by the division, correct?
Yes.
And none of those parties.
As well as additional parties that are now of interest at the time of the hearing.
And included in that list where it was the State Land Office and the BLM, correct?
Yes.
Thank you, Mr. White. At this time, Madam Chair, I would move the admission of exhibits A through G into the record if there are no objections.
Mr. Tremaine, any objections?
No objections.
Any objections from any of the commissioners?
No, Madam Chair.
No, Madam Chair.
All right, exhibits A through G are entered into the record.
Madam Chair, at this time, I have no further questions of Mr. White and will pass Mr. White for questions by the division and the commission. Thank you.
Thank you. Mr. Tremaine, do you have any questions for the witness?
Very briefly, I think I have one question, Madam Chair.
Okay, go ahead.
Mr. White, I think we've heard today that as Pinon has kind of developed its business, that the need for maximum injection rate has changed from what Ameridev originally or projected to be 12 now to 20. My question for you is there any reason to believe that as Pinon continues to develop this facility and develop its business that you would expect any further increase in injection down the road?
So I don't know if I would have the I guess the forecast data or the demand data that Mr. Green may have that kind of would be allow me to be better informed in answering that question. What I would suspect is, or what I would say is, if that was pursued in the future, then it would be, reasonable and similar investigations as to the ability of the reservoir to continually either maintain or to receive those fluids without detrimental effects would need to be done as well. But whether or not it's forecasted and likely to be requested, I don't think I have. I don't know if I could speak to that.
I understand. Thank you. That may have been a better question for the other witness. In terms of that process, if Pinon determines in a year or two that it desires 25 SCF of injection or 30, would Pinon undergo a similar process of updating the modeling and running these projections?
I would assume so, and I don't think it's been discussed, but part of the requirements of the original order required a periodic and continual update of that geologic model, which, to be frank, is going to, our understanding is going to improve with every iteration of that, because we can start to see how our model predictions line up with what we're actually experiencing in terms of operating pressures, and essentially take each of those to kind of history match and kind of true up our model and our understanding. So I would assume, based on my experience with Pinon, pursuing any approval for any additional increase would be accompanied by a significant investigation into the feasibility, and as well, the ongoing requirements of the order will help to kind of keep our understanding of the feasibility in check, I think.
Okay, thank you. No further questions.
Thank you. Commissioners, do you have any questions for the witness?
No, Madam Chair.
Yeah, Madam Chair, I do have questions for
Hi.
the witness. Okay. Okay, yeah, so Mr. White, uh, so we do have the Woodford Shale being the cap rock for the Devonian that we are that you Pinion is targeting. So, but also there has been a lot of production, more like horizontal wells through the Woodford Shale. So my first question is, in the location that Pinion is looking at, are there any activities going on in the Woodford which can more or less compromise the integrity of the ceiling?
No, at this time, I am not aware of any Woodford Shale development that would be occurring in the area of the Pinion Wells. Overlying production is primarily dominated by Bone Springs and Wolf Camp, which is separated by thousands of feet of strata.
Yeah, so you talked about how you've used information from the AGI #1 well to update the model that you presented to us today. And also even now you have the AGI #2 still being drilled at this point. Let me ask, did Pinion take any call from the AGI #1 well?
Yes, they took sidewall cores.
So did they measure permeability from this core?
Yes.
Now, I didn't see it in the modeling where you included that kind of permeability in your modeling. Aside, you talked about, and even I didn't see the core measurements being made mention of. You talked about using the DST to calculate or to more or less get the permeability. So, would you confirm to the commission whether you incorporated the core measurements, permeability measurements into the modeling efforts?
So the core measurements were utilized to inform our revisions to the model, but ultimately in some of the more productive intervals where injection or our step rate injectivity tests and fall off tests, where those tests indicated the most volume of fluid was going, such as the upper Devonian and Fusselman intervals. Those intervals are usually productive because there is a bit of fractured solution enhanced porosity or solution enhanced rock there. And so naturally core recoveries along those most productive intervals was not very good. Most of the core recovery that was successful was in the overlying Mississippian section, the Woodford Shale section, and then some more of the tighter intervals of the Siluro-Devonian, kind of in between the Fusselman porosity and the upper Devonian porosity.
So would you say that probably if Pinion could have recovered a conventional core compared to a sidewall core, probably the recovery rate could have been improved?
Potentially.
So in the DST measurement, you also measured reservoir pressure, right? So I wanted to know if you went back to look at the 0.43 PSI per foot, initial reservoir pressure that you used in the mod to initialize the model, did you go back to check for consistency?
Yes, the geomodeling team would have done that.
Would have, or probably they did, or you're not sure?
At this time, I would need to confirm that.
Okay, yeah,
But,
because that is very necessary, as
yes.
because we are using 0.43 psi per foot, which is a good assumption, but you had the opportunity to do DST, so definitely you measure the reservoir pressure at that point. So you want to make sure that you check the consistency in there, and if not, probably in the next iteration of the models, you probably have to check into that.
Yeah.
So you talked about the porosity permeability relationships, and you made mention of the Whelan R35 that you used. So I want you to be clear to the commission how the permeabilities were modeled. Is it based on geostatistics or based on the Whelan R35 equations?
So the way, from my understanding, the way permeability is populated in the model was using the Winland R35 method. And that was done for the purpose, or the purpose in utilizing that method was because I guess more standard distribution methods really didn't produce any simulation cells that were lower than 0.1 permeability. So, or 0.1 millidarcies permeability. So we didn't find that to be reasonable with respect to how these wells behave. And so it was recommended that method be taken to ascribe permeability characteristics within the simulation space.
That was great. So you talked about how you use acoustic impedance inversion for the porosity. So you have a big seismic, so at least you were able to infer porosity from the seismic. I didn't see a lot of information on that. So can you clarify that you were able to do inversion on the seismic to get the porosity to help improve the model?
So impedance data were available to us for review. The inversion was not completed by GeoLex, and ultimately the way that was incorporated into the model was such that you know, that all of the licensing terms of those data are not breached. So while the model was not constructed to directly represent any of that, it was utilized to kind of better inform and make more realistic those results.
Thank you. So let's get to the modeling part. So you have one saltwater disposal well, and then also the AGI #1 well. So first of all, are they all active injecting now?
I'm sorry, can you say that again?
So the saltwater disposal well and the AGI #1 well, are they all active now?
Yes.
So then in your plots profiles that you showed, I didn't see any history matching work done before the forecast.
Yeah, and ultimately that's going to be as more AGI #1 and #2 well data are yielded from their operation. With the commission's schedule to revisit this model, those will be the long-term goals of this evaluation. But ultimately on the initial investigation, it was not part of the scope to include all of those. But rather to take a conservative approach for operating volume to assure that our confidence in the reservoir's ability to maintain that is in place.
So what is the distance between AGI #1 and AGI #2?
Bottom holes are separated by a little over 3,000 feet.
3,000 feet. So are they not close enough? Or is it okay? Because I'm thinking about, did you guys do any interference tests to make sure that you are maximizing the pore space, to be able to co-inject both wells without any pressure issues?
So the main motivation between separating the well bores was ultimately to take what information we received from drilling the AGI #1 well and identify what appeared in the seismic data to be an even better potential location in terms of reservoir characteristics. So that location was cited based on kind of a better understanding of what the data in the seismic survey really mean. So that was the primary motivation for selecting that location.
Mr. White, in the fault modeling, so you showed 2 faults that were incorporated in the model. Now, I saw that these are non-transmissive faults, right? So it means that it has transmissibility 0. There is no flow across. Now, if you look at so if you look at slide number probably 28, so why did you not run other scenario where these faults were opened? Or even let me ask it this way: how was the transmissibility calculated for this particular fault?
So based on the reason it was not explored for this simulation is that we made this, or in our experience, these faults that are generally confined to the lower Paleozoic section don't have a lot of extension vertically up into other producing zones. You know, most of the population of these faults have behaved and are demonstrated as competent traps. And so we felt that that was the most reasonable assumption for this area.
So in that case, you don't believe that there's any chance for this box to be opened?
I'm sorry, I believe either mine or your connection broke up. Could you repeat that?
So I'm saying that, so are you confident, saying to the commission that these faults are strictly closed and cannot be opened?
I'd say that is the most likely scenario and provides the most conservative estimate of the plume migration, in that assuming these faults to be closed significantly reduces the available reservoir in which acid gas can occupy. And should the open fault simulation be considered, it's likely, based on the well data or the existing wells, it's not likely to come into contact with any other Devonian penetrations. So having an understanding of the maximum extent that the plume may reach may be more, at this time, a more useful investigation for us to assure that we don't reach any penetrations that could be conduits out of the reservoir.
Mr. White, so let me go back to why I asked about the core measurements. So I presume, based on your testimony, Pinion did routine core analysis on the core, on the, let's say, the sidewall core that he took. What about special core analysis for relative PEM and capillary pressure measurements?
So I don't have those data, or not familiar with the specifics, but I don't believe that those were completed.
Yeah, so that is, if you can bring up the slide number 28 of, one of the plumes that you showed. So my main concern is, how did Pinion calculate the irreducible water saturation? So what was the source of the relative PEM curve that you use in the modeling?
So the source of, well, there were multiple relative PEM curves utilized in the models to characterize the behavior within each zone. And those were determined from a collaborative effort of evaluating the well data collected and reasonable assumptions for our understanding of the reservoir in this area.
Yeah, but don't you believe that if you want to get the actual data, then getting the core and then doing the flow through experiment on the core, like a special core analysis, give you the hard data for you to be able to get the curves? Because if you look at the plume that you are showing, I want to see, in terms of what is the maximum saturation of the water that cannot be displaced by the injection that you are putting into the well. And if you do not do the relative PEM experiment, how do you account for that irreducible water saturation?
Well, I certainly do believe that that may be the most suitable approach, but I don't know if the actual core recoveries would have been truly reflective of that, and when you have the disparity in where injection fluids are going versus where your core recovery occurs.
So let me try to wrap it up quickly. And I'm sick today, so probably it's good for you. But let me ask, what was the minimum horizontal stress that you use in calculating the maximum fracture pressure?
You're referring to the latter portion of the presentation where fault slip probability?
Yeah, but even within the modeling, so let's say you use the minimum horizontal stress to more or less know the maximum bottom hole pressure that you can go, right? So in the current modeling, what was the minimum horizontal stress that you utilized? And I'm sure you used that in the force slip analysis as well.
Yes, and that particular variable or value is not shown in this. However, it is ingrained in the simulation, and we can, if over a break, we can probably grab that number and let you know what it is, what the model assumption for that is.
Okay, so it would be good that you include that in the final version, that the final documentation. And I presume it is a normal 14 regime, right?
Yes.
Okay.
I
Last
just
one.
want to jump in real quick. I think if Dr. Impoma, if they haven't provided us with the information previously, they've submitted their pre-hearing statements, they've submitted their exhibits. They can't really provide us with more information if they didn't think to include that in the beginning.
And I can provide a little bit of more information on that. So the way the Stanford model is constructed, that those values that Commissioner Ampoma is requesting is represented and defined in that particular model by the A feed parameter. So what I can do, maybe we can, obviously that A feed parameter can be utilized to see what those stress conditions are, if we cannot provide that.
Yeah, and Mr. White, let me be clear that the questions that I'm asking is probably mostly for the regulator to see how they review the models that are presented, to the commission. So the last one, you use Eclipse for the modeling. Did you look at the reaction between the injected fluid, that is the H2S, and the CO2 with the formation fluid and also the metrics to see how the injection that you are doing, how the fluid is stored?
You mean in the simulation itself, does it consider those other sinks? No, it does not.
Why?
At this point, I just don't think enough information has been explored in order to pursue that type of investigation. The modeling, we could also, and maybe a longer term goal for this as the model is revisited, is even to produce a dual porosity model where we start to consider the role of fractures versus matrix permeable porosity. So I think at the point where it becomes or the data available to us become the operating data to where we can start to further refine that. Some of those things kind of be brought into scope with that.
Thank you, Mr. White. Madam Chair, I'm going to end here. Thanks so much.
Thank you. I think you very eloquently asked the majority of my questions, so I do not have anything. Actually, I have one question. The only question I have is, I just want to make sure I understand what you guys think is gonna be the injection pattern. Like, how are you planning to use the wells? Are you planning to inject in one at a time? Are you planning to inject equally in both? With a total capacity of 20, what is the kind of injection plan?
Yeah, so as we simulated in the plume modeling investigations, we think the long-term average for this is going to be 10 and 10 into each, which represents, with bottom hole locations separated by some distance, we feel that's the best management of our impact to the reservoir. So long-term, we feel that it's going to average like that. Pinion's intent, if I understand correctly, is that these wells will be operated simultaneously, maybe with some small fraction going to one well and the majority going to the other well. So maybe 5 and 15 for a period, or 6 and 14 for a period, and then alternating those conditions between the two wells, such that operational readiness of both systems is maintained at any point, and we don't deal with any scaling or issues that may result from downtime of the one well completely. But I think over the long haul, the 10 and 10 is how it will likely average out.
Okay. And then if for some reason both wells were to go down, so the point of the redundant wells, if one well goes down, you can shift injection to that one or to the other one. If both wells were to go down, what is the operational plan?
So I think in terms of how that is planned out, maybe a question more suited for Pinion. In considering the downtime of one well, the step rate injection tests that we've completed on the Independence AGI #1 are currently supportive that if for a period of time, one well had to take all of the flow, then that would be a reasonable operating parameter for at least a short period. In the event that both wells go down, I know Pinion does have, or the operators that Pinion service, many of those operators have the ability to immediately and remotely shut in a lot of the wells that are contributing to that gathering system. So there is some volume that can be immediately shut in without going to flare. And I think, again, from my experience, I think this can be done in a matter of minutes for a lot of their infrastructure. So I think I think in the event that both wells go down, there's certainly some options for Pinion.
Okay. That's all of the questions that I have. Mr. Rankin, do you have any follow-up?
Madam Chair, I do not. I appreciate the commission's questions, and at this time, we have no further questions or information to present, so we rest our case. And I guess now being noon, unless we want to proceed with the division's case, we can proceed as the commission desires.
Okay. Mr. Tremaine, how long do you expect your presentation to go? I think we're going to take a break, but just for planning afterwards.
Well, I think that ours will be fairly quick. I will say less than half an hour.
Okay.
We were not planning to get into kind of extensive details, but are available for additional questions, and I do expect commission questions. So I'm not sure how long that will go.
Okay. All right. It's 12:05 basically. Let's come back at 1 and we will pick up with the division. I will leave this going, so you're welcome to either stay on, just turn off your video and mute, or you can drop off and then come back on. Thanks. All right, everybody, it's 1 o'clock, and we will pick up where we left off, which was, I think, starting with the division, but I think we have maybe a piece of announcement prior to that.
And that's your cue, Dr. Mpoma.
Yeah, thank you, Madam Chair. In the interest of justice, I will ask to recuse myself for the remainder of the proceedings. Thank you.
Thank you, Dr. Mpoma. And I think, well, with that, yeah, thank you.
Okay. All right, so we will proceed, I guess, with just Commissioner Bloom and I. That is still quorum. And so we are able to proceed. All right, Mr. Tremaine.
Madam Chair, the division has one witness, Mr. Dylan Rose Koss. Call him at this time.
All right, Mr. Rosecross, can we hear you?
Can you hear me?
Yes.
Good.
All right, would the court reporter please swear in the witness?
Okay, can you please state your full name for the record?
My full name is Dylan Henry Rose Koss.
Thank you very much. Can you please raise your right hand? You swear or affirm that during your testimony today, you will tell the truth, the whole truth, and nothing but the truth.
I swear and affirm.
Thank you very much.
Thank you.
All right, go ahead, Mr. Tremaine.
Mr. Roscos, where do you work?
You know, I work for the state of New Mexico within the Energy, Minerals, and Natural Resource Department, specifically within the Oil Conservation Division, UICT.
And what is your specific position within the division?
I'm specifically classified as a Petroleum Specialist Advanced.
And could you please summarize your responsibilities as a Petroleum Specialist Advanced for the commissioners?
You know, by and large, the generality of what you would say I do is review applications for compliance with OCD's rules regarding the prevention of waste and the protection of correlative rights, public health, and the environment. I also serve as a technical examiner for these hearings at OCD level hearings. Specifically, as a member of the UIC team, what you would say I do is applications and compliance for Class 2 disposal wells within the state, UIC Class 2 disposal wells.
Thank you. Mr. Roscos, have you prepared a CV for this hearing?
I have.
And is that marked as proposed OCD exhibit number 1?
It is.
And is that a true and accurate description of your relevant education and experience?
It is.
And now, would you please summarize for the commissioners your education and experience?
Sure. Well, as you can see on the CV, I have over 8 years of experience in kind of public or resource management. You know, prior to that, or the way I got into the field, began at UNM many moons ago, where I received a bachelor's in science and a distributed science minor in environmental science, which I followed up with again at UNM, University of New Mexico, with an Earth and Planetary Science degree, which is their UNM's form of a geology undergraduate, which I then proceeded to follow up with at the University of New Mexico Tech, where I received a master's degree in geology. And during that time, you can also see from my CV that I have 3 peer-reviewed publications and 5 conference level papers regarding the underground kind of reservoir characterization and the underground sequestration of carbon dioxide. So my job following my master's degree and time at New Mexico Tech was with a resource consulting firm, water rights consulting firm in Santa Fe called Glorieta Geoscience. That led me, which I followed up with by taking a position with the Oil Conservation Division as an environmental specialist, mostly reviewing spills and releases in the oil field. And then I moved into, and I've held the position for 3 years now, as the Petroleum Specialist Advanced with the UICT.
Okay. When you were getting your master's at New Mexico Tech, did you specialize in any particular areas?
Yes, you know, I did specialize at New Mexico Tech in petroleum geology and reservoir characterization, and actually garnered a lot of experience at my time there in Krell reservoir modeling and simulations, specifically kind of relating core measurements to reservoir modeling.
And for what types of cases do you typically or normally appear as a technical examiner for the Oil Conservation Division?
Sure, yes. You know, so by and large, the cases that I hear as a technical examiner are for compulsory pooling. But when my specialty is called on the most is during hearings regarding contested saltwater disposal wells.
Okay. Thank you. Have you ever testified before the commission before?
I have not.
All right. Madam Chair, at this time, I would move admission of OCD Exhibit 1, Mr. Dylan Roscos's CV, and also ask that the commission qualify Mr. Roscos as an expert in the areas of petroleum geology, petroleum engineering, and underground injection.
Mr. Rankin, any objections?
No objection.
Okay. Commissioner Bloom, any objections?
No, Madam Chair.
Okay. OCD Exhibit 1 is entered into the record, and Mr. Roscos is certified as an expert.
Thank you, Madam Chair. Mr. Roscos, have you, I want to refer you to the particular matter at hand. Have you had an opportunity to review Pinion's application on behalf of the Oil Conservation Division?
I have.
And when you review an application such as the one submitted by Pinion in this case, what types of things are you looking for?
You know, typically when an application for injection comes before the division, we first review it for simple administrative completeness. And the administrative completeness review involves checking notice to affected parties and verifying that all affected parties were noticed. And should the application be clear of any issues in terms of general completeness, it moves on to a technical review where the kind of aspects of geology and engineering related, to correlative rights and protection of the health and the environment are evaluated, namely wellbore design, fix formation tops, such as that, and ensuring that the well is going to be constructed in a manner to protect the water rights and correlative rights. And should an application from there have any issues or be protested, is when it's elevated to a OCD hearing level, at which a more thorough review is undertaken of the technical aspects of the application, but namely in those instances, by and large, for correlative rights issues, hearing out affected parties. And in this case, for tag or acid gas injection wells that come before the commission, a further analysis of the technical kind of specifics in terms of the computer simulation modeling are reviewed and evaluated for efficacy and validity.
Pardon, I muted myself there. And Mr. Roscos, did you conduct the review that you described of Pinion's application for this case?
Yes, we did. I and the other members of the UIC technical team did carry out a thorough review of this application. And since the filing of the pre-hearing statements, have indeed reviewed all of the materials submitted. And as it stands, do not disagree with the modeling or oppose the application. However, the division would like to take the opportunity to reiterate its stance that, it agrees that AGI wells present a unique oil field opportunity, but they also represent a unique oil field risk. And therefore, we maintain that they be regulated consistent with these elevated concerns for correlative rights, waste, and public health in the environment, and believe that future major mods should return to the commission, and that the redundant well is still necessary, and that all of the conditions set forth in the existing order need to be adhered to.
So, Mr. Roscos, am I understanding correctly that consistent with what you just outlined and the previous conditions set forth in the order, that the division is not recommending any additional or new conditions of approval for this application?
No, we're not recommending any additional conditions of approval at this time.
Just a moment ago, you referenced kind of unique risks associated with acid gas injection wells and the types of things that you as the technical reviewer looked at the application, reviewed the application for. Has OCD discussed these general concerns with Pinon directly?
Yes, we have. The OCD at the division level did have a meeting with Pinon Midstream preceding this case, in which these concerns were elaborated on, and basically Pinon explained how their patrol model was generated and updated with the latest information that was made available to them through the drilling of the Independence AGI #1. And that presentation was consistent with the material presented today at hearing.
Okay. I now would like to draw your attention to what's marked as OCD Exhibit 2. Mr. Rosecross, what is Exhibit 2?
Exhibit 2 is a list of the current AGI wells that are tracked and monitored for the state of New Mexico by the UIC team. And the list is really just presented to illustrate the current state of AGI wells in the state and highlight the elevated regulatory lens used to monitor these wells. And we'd also just like to say that we're ready to answer questions that the commission might have regarding the state of the state's AGI well program.
Okay, thank you. Madam Chair, I would move to admit OCD Exhibit 2.
Any objections, Mr. Rankin?
None.
Commissioner Bloom?
No, Madam Chair.
Okay. OCD Exhibit 2 is entered into the record.
Okay. So, Mr. Rosecross, I'd just like to ask you directly, at a general level, what are the unique risks that OCD associates with AGI wells?
Well, first and foremost, the general risk of it being kind of a potentially dangerous gas that's going to be transported at high pressures and concentrated. But in addition, the nature of that injectate poses kind of engineering considerations, such as corrosivity and additional correlative rights risks. So based on those facts or aspects of it, it believes that there's those additional consideration and level of scrutiny needed to elevate it to the commission level of consideration.
And in conclusion, Mr. Rosecross, is, in your opinion, the Pinon application adequate as you reviewed it to address OCD's concerns with waste, correlative rights, and protection of public health and the environment?
It is.
Thank you. No further questions.
Mr. Rankin, do you have any questions for the witness?
I do not.
Commissioner Bloom?
No questions, Madam Chair. Thank you.
Okay. I have a handful of questions. Mr. Rosecross, are you familiar with, let's see, the GeoLex presentation that was presented today?
Yes, Madam Chair, I am.
On slide 41, so it just calls out the injection wells in the vicinity of the proposed AGI. There are 7 wells. I think within 8 miles of this proposed AGI. Are there any concerns with interactions between these wells?
I believe that the concerns that there would be are addressed in their modeling. that they presented today. And so division appreciates that all of those wells were incorporated into the model, and that the model was generated running those wells at, the model was generated conservatively. So all of those wells were run at higher rates, presumably, potentially, than they actually are going to be operated at. And so the modeling performed puts to rest many of the concerns, if not all of them, regarding those wells in the area.
Okay, most of them look like they're a ways away. It was, let's see, 30-025-25046. That's relatively close by. But the division, based on the modeling, doesn't have any concerns. I think that's the West Gel B Deep number 1.
Yeah, the division would have more concerns, it would have significant concerns regarding permitting additional wells in the area. So any applications up for review within a broad AOR will receive strict scrutiny. The West Gel B Deep is existing, and based on the modeling suggests that both of these wells can coexist at their proposed rates.
Okay, so if the division were to get, well, maybe, so these are the existing wells. Do you know if there are any proposed wells nearby, like that are in application?
There aren't any proposed wells that are near approval. And anything in the area, it's not the most popular area for SWD applications. So they've staked their claim here to
Okay.
this kind of 3 mile area.
But so if the division were to get applications within the area of review for this AGI, would there be additional scrutiny on those applications for potential interference, or how would that be handled?
Anything within 1.5 miles of this well wouldn't be permitted. Radius of this well, and anything within a 3 mile radius, I would say. The other flag that comes up in this instance is the proximity to faults and structure in the basin. And so it is on the eastern portion of what's considered like the major Delaware Basin. So, moving east, all of those wells will kind of pose additional kind of review in regards to induced seismicity concerns. So fault slip modeling will be a bare minimum. Anything that's within 3/4 of a mile of one of these major map faults requires a large additional scrutiny.
Okay. So you mentioned a meeting with Pinion and talking through some of the division's concerns. Were there any modifications that came out of that meeting? Was there any change to the application or change to conditions, or anything that came as a result of that meeting?
No, nothing major came out of that meeting. Just kind of assessing the state of their modeling is really what came out of it. And Pinion and Geolex was just forthcoming with kind of how they put together the model and what they were going to present here today. So I believe, the only additional things that came up that I believe were addressed by Mr. Ampama and Mr. White was the way that the faults were modeled within their simulation. And so those were discussed before the commission.
Okay, and the division is not recommending any additional conditions or modifications to the current order other than you're essentially updating the limit per day, but nothing else.
The division was happy to see the additional scrutiny provided by the commission and through the modeling to validate the request for the additional injection, and was happy to see all of the additional information provided to justify the request, and believes that future modifications or significant major modifications to the well or to this injection limit should again come before the commission. But beyond that, we did not oppose the application. We would suggest it would be nice, because GeoLex is going to be updating the model periodically as per the conditions of approval of the initial order, that the considerations raised by Dr. Ampema are considered and incorporated into future models as they gain more information and have more injection history to history match their modeling.
Okay. Does the division, so when somebody comes in for a modification of an application or modification of an existing order with a new application such as today, does the division do a compliance review of the well that is being modified?
Yes, Madam Chair.
And have they complied with all the requirements so far for this well?
Yes, Madam Chair.
Okay.
As far as the current status of both of the wells, the redundant well as well, GeoLex and Pinon have been in compliance.
Okay. For the other, I think it was in Exhibit 2, the division, in some of the other AGIs, so it's the division's practice to require a redundant well. Is kind of the injection pattern here similar to other wells where they're intending to use both wells simultaneously? Or is that unique to this scenario and most just use one?
A review of this list, one of the things that I think it does is illustrates the kind of chronology of the division's history with these and the increasing complexity and kind of learning curves that the division's gone through. And so having a redundant well is a new phenomenon based on previous learnings with the division. And so the other case that I'm most familiar with in which a redundant well is used, the redundant wells in the Delaware Mountain Group. And so there's additional concerns regarding the Delaware Mountain Group. And so my understanding was that that well was going to be used as a backup in case one goes out of commission, and then only used then to avoid the kind of correlative rights risks associated with creating a large acid gas plume in the Delaware Mountain Group. And so the division has less concerns with the redundant well being in the Devonian in this case, and the wells being utilized in that manner.
Okay, so the division is comfortable with both wells being used at the same time as long as it doesn't exceed the 20 million a day?
Yes. Yes.
All right, I think that was my last question. Mr. Tremaine, do you have any follow-up for the witness?
No, Madam Chair. Thank you.
All right. Thank you, Mr. Rosecross. You are dismissed.
Thank you, Madam Chair. Thank you, Commission.
Mr. Rankin, do you have any brief closing statements?
Thank you for the opportunity, Madam Chair. The only thing I will say is we appreciate the commission's time and attention during the fairly technical presentation today, and we appreciate the questions and concerns and focus on safety, health, and concerns around correlative waste and correlative rights and prevention of waste. But no additional comments other than to say, again, we appreciate the commission's attention and consideration, and we ask that this application be approved with the existing conditions under the existing order.
Thank you, Mr. Rankin. Mr. Tremaine, do you have any closing statements?
Very briefly, Madam Chair, the division asks that the commission consider the position that the division outlined today, and if should the commission approve the application of Pinion, that you do so in a manner that's consistent with the order to be amended in terms of the other conditions and requirements, such as leaving in place deadlines for the completion and injection deadlines for the redundant well, and the various other requirements. The commission may consider Mr. Rosecos's recommendation of considering updates to the modeling as they're available through Pinion. But other than that, the division does not have any other objections or items to raise regarding the application. Thank you.
Thank you, Mr. Tremaine.
Madam Chair, before you close up everything,
Yep.
because you have not closed the evidentiary record yet, I just want to clarify with the party, because we heard some pretty hefty technical stuff today, that the focus of this whole hearing, and I'm going to say this and hopefully not screw this up, is purely to address the MMSCFD from order R21455-A, and basically changing the language in that order, modifying it from 12 million to 20 million. There's no other changes that are being requested specifically here. Is that right? And either party can answer at any point. I just want to make sure we're clear on concepts here, so there's no vagueness or errors.
Madam Chair, if I may just make one additional clarification for Mr. Moander's statement. The only, I guess, slight modification there would be that the requested increase in injection rates would be applicable to not just the AGI 1, but would be to both wells. So the way the order reads now is that it's applicable to the AGI 1, and so we want to make clear that the amendment is for allowance of the 20 million standard cubic feet per day into both wells, combined total.
So a maximum between, just to be explicitly clear, a maximum between the two wells is 20 total. We're not talking 40.
Correct.
And Madam Chair, in response to that, what Mr. Moander outlined is consistent with the division's perspective. The division's primary concern here was making sure that the technical basis, primarily the modeling, but the entire technical basis that was the justification for the previous order, was updated to reflect the additional injection amounts. And so that's why we have very narrowly focused the presentation here today on OCD's review of that modeling and kind of that process. So our understanding is, Mr. Moander, is that yes, that is correct. It is that one change, and that, to clarify OCD's previous statements or mine, the references to like major modifications should in the future Pinion ask for an increased injection. You know, the technical basis for this hearing and any subsequent order would be a technical basis to justify 20 million standard cubic feet per day, not something in excess. So that's why OCD's drawn that distinction that, future major modifications such as another increase in injection, OCD asked that consistent with the existing order, those changes like that come back before the commission.
Thank you, gentlemen, because nothing will complicate one of these issues more than lawyers and engineers talking to each other. So I appreciate the clarification.
Any other questions, Mr. Moinder?
No, Madam Chair, thank you for indulging me.
All right, the record of this hearing is now closed. The commission will immediately deliberate so as to reach a final decision on the application. I move that the meeting be closed pursuant to the administrative adjudicatory deliberations exception to the Open Meetings Act, Section 10-15-1H3, to deliberate in this case. Is there a second to my motion?
Madam Chair, I second.
Mr. Moinder, would you please do a roll call vote?
Happily. Commissioner Bloom,
Approve.
Madam Chair,
Approved.
motion carries, and this hearing is now closed for deliberation.
Okay. Everybody can remain on here. Let's see, it's 1:34. How about everybody come back at 2? And I will give, if for some reason we're not done with deliberations by 2, I'll hop back on and give an update for everybody. But we will plan to be back on here by 2. And then Commissioner Bloom and Mr. Moander, we can jump on the other meeting for deliberations. All right, thanks everybody. We'll see you at 2. Okay, it is 2 o'clock. And let's see. The commission meeting and the record is now open. And the discussion during the closed session was limited to deliberations in case number 22977. I move to go back on.
Chair. I think you should probably also note that Dr. Mpoma did not participate in, was not involved in deliberations.
Thank you. And during the session, the conversation was limited to deliberations in case number 22977. And the only participants were myself and Commissioner Bloom, and counsel of the commission was present. Dr. Mpoma did not participate in deliberations or discussion. And with that, I would move to go back on, or to reopen the meeting. See, as it was closed with the deliberations exception to the Open Meetings Act, Section 10-15-1H3. Is there a second?
Madam Chair, I second.
Mr. Moander, would you do roll call, please?
Yes, Madam Chair. Commissioner Bloom,
Approve.
Madam Chair,
Approved.
motion carries.
All right, great, thank you. All right, so in case number 22977, I move to increase the injection rate to a combined total of 20 million standard cubic feet per day. That is shared between AGI well number 1 and AGI well number 2. The commission is to retain authority for any major modifications to a future application. And then the commission would also, I move to also add a condition that has been in some previous AGI orders prior, such as AGI order R-20694, and which shall state the operator shall every 2 years, once injection begins, provide the division with a report that compares the reservoir pressures, volumes injected, and projected tag plume extent to those estimated in the C108 application, together with summarizing the AGI well's performance, including but not limited to injected volumes by fluid type and reservoir pressure, and potential calibration of models due to information collected during the prior 2-year period. AmeriDev, I think in this case, will use data collected and analysis conducted pursuant to this order to prepare the analysis. The report shall include an updated model of current and projected plume migration and shall use the modeling technology and standard use at the time of the report and any available information about plume migration. At the request of the commission, the operator shall provide in-person presentations of its data and analysis regarding the AGI well's performance. And the inclusion of this is due to the proximity of several other injection wells within the area and within the potential plume to determine how those interact with one another over time, and if the modeling that was based on these initial parameters remains accurate. And with that motion, is there a second?
Madam Chair, I think I heard you mention AmeriDev in the middle of that. Did you mean Pinon?
I did.
Okay. So we'll make sure to make that change there. And
Is
with that
the
slight
is the
modification.
motion modified, Madam Chair?
Yes.
Okay. So now we're back on track. So back to Commissioner Blue.
All right, so we've modified the motion to include mention of Pinon, striking AmeriDev, and I second this motion, Madam Chair.
Would you please do a roll call vote, Mr. Moander?
Happy to do so, Madam Chair. Commissioner Bloom?
Approve.
Madam Chair?
Approved.
The motion carries.
Okay, Mr. Moander, would you please update the order and then provide the order for final vote at our October 13th commission meeting?
Yes, ma'am.
Thank you. And with that, is there an update on any pending litigation?
Believe it or not, there is a little bit. I checked on A1CA 39578, which is the marker appeal. The court has not taken any action since February. I'm not sure what's going on. I think I'll take a deeper look at that. The other case is the Ragsdale District Court Rule 73 appeal. The reply by Ragsdale was filed late yesterday, which completes the opening briefing cycle agreed to by the parties. And Ragsdale should be, counsel for Mr. Ragsdale should be submitting for hearing and notice completion of briefing today. So I anticipate a hearing of some sort will likely be set probably in the next 30 to 45 days.
Thank you. Is there any other business before the commission today? All right, our next meeting is October 13th. And we will see many of you there. Thanks, everybody, and have a great rest of your day.
Thank you all. Appreciate it. Take care.